Hello and welcome to the exciting world of the R programming language. R is one of the most powerful programming languages for statistical computing and graphical presentation to analyze and visualize data. And in this course, I am going to show you how to code with the R programming language from the R basics to the advanced concepts, step by step. And also we will explore how the R programming language can be used today for data analysis and the production of beautiful data visualizations and graphics. The best part is every single topic and tool in this course will be explained theoretically and practically with real examples, step by step from the ground up. This course will cover all the R essentials needed for everyone, such as the R working tools and environment for professionals, the R syntax and how to explain and describe the code using comments, variables, values and assignments, all the data types available in the R programming language, performing mathematical operations, type conversion, built-in functions, and many useful built-in functions for mathematical operations. Working with collection of characters and strings in the R programming language, also essential character operations, step by step. Logical values and booleans. Handling different operations on variables and values by using different types of operations. All the data structures in the R programming language, and also all the essential operations for these data structures, one by one. Decision making by using conditional statements in the R programming language. Repeating block of code and iterating over collection of characters or collection of values with loops. Functional programming in the R programming language and code reusing. Statistics and data analysis concepts such as datasets, many built-in functions, techniques and tools for statistical operations. And also graphics and data visualization in the R programming language such as drawing points, line plotting, pie charts, bar charts, histograms, and many more. You will learn all of that and more. You will learn and understand all these concepts one by one in detail. You can use the R programming language for free. You can download and install it on your device for free. And this language is very widely used by professional statisticians and data scientists. It's also very popular in certain application areas. R is a dynamically typed interpreted language and is typically used interactively. This language has many built-in functions and libraries. You can use it for statistics and data analysis easily. And in this course, I'll show you all these concepts in detail. My name is Ahmed Ibrahim. I am a data and machine learning software engineer, and I'll be the instructor for this course. And if you have any questions during this course, please send me your questions and I'll be very happy to answer your questions as soon as possible. R is available for Linux, macOS, and Windows. The R software can be downloaded from this website by using this link or this URL for the comprehensive R archive network. Installing the R programming language to the local computer is very easy. First of all, we must know which operating system we are using so that we can download it accordingly. R is a cross-platform language, so it will work on Windows, Linux, and macOS also. In some Linux distributions, R is installed by default, which we can verify from the console by entering R. And to set up the R programming language on your local device, we have to download the R Launch installer or the R setup from this website. Let's do that. Select download R for Windows or any operating system you are using. Then I'll hit install R for the first time. After that, you can download the latest version of the R programming language for the Windows operating system. Open the install launcher after downloading it. After selecting the language, hit next and select the location, hit next and choose the version you wish. Then hit next and install it by default. It's so easy process. Hit next, next and another next, and wait while setup installs R for Windows. The process, hit finish, and now the R programming language is successfully installed on our local computer. After R is downloaded and installed on your device, simply find and launch the R programming language application by typing RGUI in the Windows search. Also on Mac, you can launch the R application from your applications folder easily. Select GUI preferences from the edit menu to increase the font size. Here is the font size, increase it, for example, to 18. And after that, hit OK. In the R console here, you can execute any R code, and also you can use the R programming language as a calculator. For example, here we have 10 multiplied by 3 equals 30, 3 plus 3 equals 6. R is a command line driven program. So the user enters commands at the prompt after the greater than symbol here by default, and each command is executed one at a time. Let's try another one. Let's type another code here, and after typing it, we will hit enter to execute it. After the prompt symbol, assign a value to a variable. This value, as you can see, is an integer number. Don't worry about this code. We will explore everything in the R programming language in detail. But this code, to know how it works, how this R console works easily. As you can see, we assign this integer number 10 to the X variable. To initialize any integer number in the R programming language, use the capital letter L after the number itself, as in this example here for 10, to make this 10 as in an integer number without any decimal point. Just use it with the capital letter L, and after that you can see the print function to print X on the screen. We got the value of X, which is 10. Just call the print function after typing the code and hitting enter to execute that statement. X equals 10L, and in between the round braces of the print function, just place the variable name and then hit enter again to execute that statement to show the output, which is the value of the X variable. You can execute any code here for quick testing. This is a very useful and so easy, as you can see, but we need to use a professional workspace to write and implement large programs in the R programming language. In this course, we will use the RStudio IDE, and in the next lesson, I will show you how to download and install the RStudio IDE on your device, and also we will explore it. Hello and welcome to this lesson about the RStudio IDE to code with the R programming language easily. RStudio is an integrated development environment or IDE which allows us to interact with the R programming language more easily. RStudio is the best IDE available to code with the R programming language. It's user-friendly and open source IDE. You can use it for completely free. You can use it to write, implement, and execute all the R code easily, and also to manage the R libraries without any problems, and you can use it easily for testing the R code. There are two ways to download and install the RStudio. You can download it from the Anaconda distribution platform, and also you can download it from the official page for that IDE. Go to this website to download the RStudio and go to the RStudio desktop version. It's a free version, and by using this button you can download the RStudio IDE for your operating system. I'll download the RStudio IDE for the Windows operating system. The RStudio IDE is a cross-platform IDE, so you can download it for Windows, for Mac OS, and also for Linux. And also you can download any specific version you need from here. I'll hit the download button to start the downloading process from here. And after downloading the install launcher successfully on your device, go ahead and open the install launcher. Hit next, and install it by default. It's so easy. And after completing the installation process, hit finish. Now the RStudio is available on your operating system. Once you open the RStudio IDE, you will see these sections. You can create a script from here, create a new R script, or you can use the shortcut Ctrl+Shift+N to create a new script, a new R script, or a new R file. Let's discuss our important sections here. First of all, you can see the R file. You can type any code in that file, and you can select all the code, or you can use Ctrl+Enter to execute it to show the output in the console, or you can use the run button to execute any code in that file. And on the right side you can see the environment panel. All the variables that are stored in your program will be appeared here. In the environment section you will see all the executed variables and all the values related to these variables here, and also some information about each variable. And below this environment panel or this environment section, there are some useful tabs. All the packages available in the RStudio here for the R programming language. You can install any package easily. The working files from the current working directory, all the files. And you can see also the plots tab to show the output for any data visualization in the R programming language. And I'll show you that in this course in detail. And also you can see the help section. This is so useful to get information about any function or library in the R programming language. Let's take an example for that. Go ahead and clear the console from here, or you can clear it by using Ctrl+L. To get information about any built-in function in R, in the help menu, just type $mark before the function name and hit run, or you can use Ctrl+Enter to execute this code, and you can see in the help menu all the information needed about the max built-in function in the R programming language. And you can do the same thing with any built-in function. Another example here, the sum built-in function. After $mark, and you can see after hitting the run button or using Ctrl+Enter to execute this statement, you can see all the information about the sum built-in function in the help section. Another one, the help built-in function, and hit Ctrl+Enter or use the run button, and you can see all the needed information about the help built-in function in the R programming language. And also inside that file you can execute any R code. Just type the code and on the same line hit Ctrl+Enter or use the run button to show the output in the console for that code. Let's take a simple example. Let's use the built-in function called sum to get the sum for all the numbers included in the sequence from 1 to 10. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10 equals 55. As you can see, once you run this code, in the console by using Ctrl Enter or using the run button. You will see or you will get this output in the console easily. Thank you so much for watching. See you again next lesson. To create a new project, select new project, then save. And after that you can select the new directory option to create a new directory or a new project in the R programming language, or you can select existing directory. As in this example here, select any folder you wish and create project. To create a new project from existing folder, to make this folder as a container for our files, for the R files in this course. You can create any file in this project by using Ctrl+Shift+N, or you can use this option from here to create a new R script or a new R file. And if you try to create any file in this working directory, you will see the file name in the files section here. And you can rename that file by hitting the rename option, or you can delete it completely by hitting the delete option from here. And in the same working directory, you can create a new folder if you wish. Hello and welcome to this lesson about variables in the R programming language. Variables are used to store information and different types of data. A variable is like container for storing data. You can store strings, you can store numbers, you can store different types of data in a variable easily. And in the R programming language, there is no command for declaring a variable. You can say that a variable is created the moment you first assign a value to it, and you can assign a value to a variable by using the assignment operator in the R programming language, the left arrow operator. In other programming languages, it is common to use the equal sign, single equal sign, as an assignment operator. However, in the R programming language, it's preferable to use the left arrow operator to assign a value to a variable. This is the most common way to assign a value to a variable, because the single equal sign operator can be forbidden in some context in the R programming language. So, use the left arrow operator to set a value to a variable or to store a value inside a variable. And after declaring any variable, you can get or use its value many times in your program by using the variable name. And there are some rules for naming variables in the R programming language. Try to make the variable name short, descriptive, and describes its value. And also a variable name in R must start with a letter and can be a combination of letters, digits, period, and underscore. And if the variable name starts with a period or the dot symbol, it cannot be followed by a digit or any number. Also, a variable name cannot start with any number or underscore character. Variables in the R programming language are case sensitive, as in this example here. Name, name, and name are three different variables. Also, you cannot use any reserved keyword in the R programming language to create a variable. Using any reserved keyword in the R programming language for naming variables is invalid. So you cannot use true, false, null, if, while, for, or any reserved keyword from the R library. Just try to make the variable name more descriptive and describes its value easily to make your code more readable, understandable, also easy to be tested and maintained. Let's take a simple example to see how to declare a variable in the R programming language. You can see in this example here, we declared that variable and its name is name. This is the identifier for that variable, and the second variable is called num. The value of the name variable is Ahmad, string or character data type, and the second variable is called num. You can assign it with any name, in any valid name or any descriptive name you wish, and its value in this case is a numerical value by using the left arrow operator, this assignment operator, and you can see the value of the second variable equals 12. You can select all the statements, or you can put the pointer on the same line and hit Ctrl Enter to show the output in the console. And you can take a look at the environment panel. You will see the name variable is stored, and also you can do the same thing with the num variable. You can hit Ctrl Enter to store this variable in the memory. After running the first statement, you can use the variable name in the console to get its value, and you can do the same thing for the second variable, also num. Its value is 12, as you can see in the console. And once you run the statement, you will see the variable is stored in the environment tab here in the memory. Just declare the variable by using a meaningful name and use the assignment operator, the left arrow operator, to assign a value to it, to store a value in this variable, as we did here with the two variables name and num. And after declaring and executing the variable, you can go to the console and type the variable name, then hit enter after the variable name directly, and you will get its value, as in this example for name and for num also. Also, the print function is available in the R programming language. You can use it to print the value of name and the value of num also. Use the variable name as an argument in between the round braces of the print function. As you can see here, we have print name, and then we got Ahmad. This is the value of the name variable, and also print num, and we got its value. We got the value of the num variable, which is 12. Try to create another variable name and assign a value to it. Then use the print function to print this value, as in this example. You can use the print function to output the R code easily. You can get the type of any value in the R programming language by using the class built-in function. To get the type of the name variable, just use it as a parameter in the class built-in function. As you can see, we got character, and the same thing for the num variable, and we got numeric. We got the type of data for the first variable. For the first value, Ahmad is a character data type, and the same thing for the num variable. Its value is a numerical value, so we got numeric in the console after using the class built-in function. You don't need to design that function from the ground up. This is a built-in function, so call it only and use the variable name in between the round braces of that function. Then after typing this statement, hit enter in the console and you will get the output. Let's talk about another useful function in R. The paste built-in function. The paste built-in function is used to concatenate variables or to concatenate or join elements. For example, you can use it to combine both text and a variable in R. In this example here, we have a text or a string, my name is, then and inside the same round braces you can see we have the name variable. The name of this variable, as you can see, after comma. So in this example, the paste built-in function is used to combine the text my name is and the value of the name variable, which is Ahmad. So the output in this case, as shown here in the console, is my name is Ahmad. To clarify that, let's take another example. Call the paste built-in function, and in between the round braces of that function, use the text my name is, then comma, then the variable name called name, then another text, and the number is, then comma, then the second variable called num. And after hitting enter, we got this output in the console. My name is Ahmad and the number is 12. This is a very useful function in the R programming language to concatenate elements easily. If you want to use a variable in the console, You need to execute it first by hitting Ctrl Enter, otherwise you will get an error in the console, as in this example here. If you type num1 plus num2 for example, you will get an error because we need to execute the two variables first, and after that you can use them easily in the console without any errors and without any problems. So let's go ahead to execute the two variables by hitting Ctrl Enter, or you can use the run button. You can select all the code and hit Ctrl Enter, or use the run button, or you can put the pointer on the same line and hit Ctrl Enter to execute that statement. After executing the two statements, you will see the input in the console, and you can use them in the console. As you can see, the plus sign operator to concatenate or to combine these variables num1 and num2, and the output from this operation equals 32 from adding 12 to 20. And also you can see in the environment panel the two variables we have num1 and num2 are stored in the memory, as you can see easily, and the value of the num1 equals 12 and the value of the num2 variable equals 20. And if you want to clear the environment or the memory, you can use this statement. This statement is used to remove all the variables or all the values from the memory to clear the environment or the memory easily. In the R programming language, if you try to combine or concatenate a string and a number, you will get an error in the console, as in this example here. You cannot concatenate the value of the name variable and the value of the num1 variable, because the value of the name variable is a string or a character data type, and the value of the num1 variable is a numerical value or numeric. You cannot use the plus sign operator to combine them. You will get an error exactly as you can see here in the console. You can assign multiple variables in one line in the R programming language. The R programming language allows you to assign the same value to multiple variables. You can assign the same value to 3 variables like text1, text2, and text3 here with the same value. For example, the same value is banana in this case. If you want to print the value of text1, you will get banana. If you want to print the text2, you will get also banana. And the same thing for the last variable text3. After executing that statement, you can type text1 and you will get banana, and text2 and also banana, and the value of the text3 is also banana, as you can see. This is the easiest way for the multiple assignment operation in the R programming language. With only a single line of code, you can assign the same value to multiple variables. And as we said beforehand, you cannot start the variable name in the R programming language with a number. You will get an error if you try this. Exactly as in this example here. A variable name must start with a letter and can be a combination of letters, digits, period, and underscore. You cannot start the variable name with a number. Also, you cannot start the variable name with the underscore character. You can remove this number and put it at the end of the name, and after that you can execute the statement again. And after executing that statement for the num1 variable, you can see in the console there is no error. You can type num1 and you will get its value, as you can see, 12 without any errors. Thank you so much for watching. See you again next lesson. Hello and welcome to this lesson about data types in the R programming language. Data type is an attribute associated with a piece of data that tells a computer system how to interpret its value. Understanding data types ensures that data is collected in the preferred format, and also the value of each property is as expected. So in general, in programming, data type is an important concept. And in the R programming language, variables can store different types of data, and also different types can do different things. Variables don't need to be declared with any particular type. And after setting and creating a variable in the R programming language, you can change its type or its value easily. And here we have the basic data types available in the R programming language. The first one is numeric. Numerical number or numerical value is a number with or without a decimal point, like 11, 9.5, and also 345. The second data type is called integer. And to initialize integer number in the R programming language, you need to use the capital letter L after that number. An integer number is a number without any decimal point. The third data type is called complex. Any number that has the imaginary part with the I symbol is a complex number. The next type is called character data type in the R programming language. Character means string data type. Character data type or string is sequence or collection of characters in between double quotes or single quotes. As in this example here, we have characters in between double quotes called hello. And you can use single quotes as well to store strings or characters. The next type is called logical or booleans. Booleans or logical values represents one of two values, true or false. And in this course I will show you in detail how to use these types one by one. However, in this section I will show you how to use the class built-in function to show the data type for any value. Let's see this in action. Our first example is for a numeric. As you can see, we have a numerical number or numerical value. This value is 19.6. You can see this number is a numerical value. We assign it to a variable called numer_num and the class built-in function to get the type for that value. The type of that value is called numeric. As you can see in the console, once you select all the code and hit Ctrl Enter or using the run button, you will get this output in the console easily. You need to call the class built-in function only after assigning and declaring the variable with its value with its numerical value 19.6, and in between the round braces of the class built-in function, insert the variable name, then select the code and hit Ctrl Enter, and you will see the output. We got numeric. This is our first example. Let's try another one. The second example about integer. Assign integer number by using capital letter L to a new variable and use the class built-in function also to get the type for this integer. And you can see in the console after running this program, we got integer inside double quotes. Give that variable a meaningful name like int_num and use the assignment operator or the left arrow operator to assign integer number to this variable or to store an integer value inside this variable. This integer value in this case is 200 and the capital letter L to make it integer value, not numerical value. If you try to remove the capital letter L, it will be a numerical value, not an integer number or an integer value. And the class built-in function also after the variable declaration with its value to get the type of this variable int_num, as you can see in the console. Let's take another example for another data type. This example will be about complex. As you can see, we have a complex number 1 plus 3i. This number contains the imaginary part 3i, as you can see. So this is a complex number or complex data type. We assign it to a variable by using the left arrow operator, the assignment operator, and the variable name in this case is called comp_num. You can name it any meaningful or descriptive name you wish, and the class built-in function after that to get the type of the value of this variable called comp_num. And once you select the code and hit Ctrl Enter, you will see the output in the console, which is the type of 1 plus 3i complex, as you can see we got in the console. Let's take another example about character data type in the R programming language. We have a string or a character data type here, and this character or this string is the power of R inside double quotes, as you can see, or you can use single quotes if you wish. You will get the same result. Assign it to a variable, and we assign this character or this string to a variable by using the left arrow operator, and this variable is called new_str, and we use the variable name as a parameter or as an argument in between the rounded braces of the class built-in function. And once you select the code also and hit Ctrl Enter, or you can use the run button, you will get the data type that this value belongs to. The data type, as you can see in the console, is character in this case inside double quotes. Next, let's talk about booleans or logical values. Assign true to x, false to y, and use the class built-in function for x and y. And you can see in the console the value of x is a logical value, is logical as you can see, and also the value of y is logical also. Logical in the R programming language or booleans in any programming language represents two values, true or false, as in this example here. We have used the class built-in function to get the type of x, and also another class built-in function to get the class or to get the type of the y variable. Also, it's logical, it's a logical value or a boolean value. Let's take a look at the environment panel. After executing all these variables, you can see here each variable and its type, also its value. comp_num, it's complex, int_num, it's integer, num_str, it's character or string, numer_num, it's numeric, x, it's logical, y, it's logical also. And you can see the value of each variable in the value section or the value column. Thank you so much for watching. See you again next lesson. Hello and welcome to this lesson about comments in the R programming language to describe your code and to make your code more readable, clean and understandable. Use comments. Comments can be used to explain what is inside your code in the R programming language. You can use comments to put hints, to put explanation, and many more. Also, you can use comments to prevent the code execution when testing alternative code, and to prevent the execution for any statement, just place the hash symbol or the hash character at the beginning of that line. Comments are only for human readability, not for the program execution, so the R programming language will ignore anything that starts with the hash symbol. The R programming language will ignore any comment. All the comments inside the source code will be ignored by the program. If you try to execute program, you will see in the output there are no comments. And there are two types of comments in the R programming language: single line comment with a single hash symbol or single hash character, or you can create multiple line comment by using multiple hash symbols for each line. At the beginning of each line, insert the hash symbol and the program will ignore anything that starts with this hash symbol. And you can see here in this source code we have many comments to describe each code. and also to put hints and to make our code more readable and understandable. And if you try to run any program from the source code, you will see all the comments will be ignored by the program, and you will see the output only for the code, not for comments in the console. Thank you so much for watching. See you again next lesson. Hello and welcome to this lesson about numbers in the R programming language. There are three types of numbers in R. The first type is called numeric. Numerical number or numerical value is a number without or with a decimal point. Numeric is the most popular data type for numbers in the R programming language. The second type is called integer. Integer numbers are numerical values or numerical numbers without a decimal point. Any number without any decimal point, this is called integer. And to create an integer number in the R programming language, use the capital letter L after that number in the input, and this will give you an integer number in the output. And the third type of numbers in the R programming language are called complex numbers. Any complex number has two terms. The first term is called the real term, and the second term is called the imaginary term. If you have a number with the imaginary term I, this is called a complex number. And I'll show you these types of numbers in R in action. Let's start with numerical values or numerical data type in the R programming language. First of all, you can see a variable and its value is a numerical value or numeric, as you can see. The first number 12.9 is a numerical number or numerical data type. And also the value of num2 variable is numeric. 87 is numerical value. You can use the class built-in function to get the type for num1 and num2 to show the output on the screen through the integrated terminal, and you will get numeric for the first value for num1 value, and for the num2 value also you will get numeric. This is the type that these data types here belong to. You can say that a numeric data type in R is the most common type and contains any number with or without a decimal point, like these two numbers here. Also, these numbers can be negative, 0 or positive. After executing num1 and num2, if you want to get the value of num1 and num2 variables in the console, just type num1 and hit enter. You will get its value, this numeric data type. And also you can type num2 in the console after executing this statement, and you can hit enter in the console after typing the name num2, and you will get its value, this numerical value also 87. And you can do the same thing with any variable. If you wanna create integers in the R programming language, just use the capital letter L after that number. This example here, the value of num3 is 99, and you can see the capital letter L, and for num4 its value is a negative number, but it's an integer number without decimal point, as you can see, followed by capital letter L to make it integer. After that, to get the type for these two variables, you can use the class built-in function to get the class type for num3 and num4 also. Select all the code and hit Ctrl Enter, or use the run button and you will get integer for num3. The type that the value of the num3 variable belongs to is integer, this number without any decimal point, as you can see. And also the same thing for the second value or the second number, the value of the num4 variable. It's a negative number but without a decimal point, so it's an integer number. An integer number is a numeric data type or a numerical number without a decimal point. And to create an integer number, use the capital letter L as in this example here. Then you can use the class built-in function with that variable as a parameter in between the round braces of the class built-in function to get the type that this data belongs to, or this number belongs to. Also in the console, if you wanna get the value of num3, type its name num3 and hit enter, and also the same thing for num4, exactly as in this example here in the console. Num3, then hit enter, and we got 99. And num4 also, after typing num4 and hitting enter, we got this number, the value of the num4 variable, which is -85. Also, after creating and executing all the variables, you can see these variables in the environment tab or in the environment panel in the global environment. As you can see, num1, its type is numeric and its length is 1, and also its size and its value. And the same thing for the num2 variable, the num3 variable, and the last one we have here, the num4 variable. All these variables in the environment panel, as you can see. It's so useful. Finally, let's talk about the third type of numbers, which is complex numbers. A complex number has two terms, the real term and the imaginary term with the I part or the I symbol. As in this example here, you can see the value of x is a complex number with the I term or the I imaginary part, and also the same thing for y and for z. 2 plus 9i, then 1 minus 4i, then the last one, the value of z equals 7i, the imaginary part only, and this is considered a complex number because any number with the I symbol or with the I imaginary term or imaginary part is considered complex. Now after that, you can use the class built-in function to get the type for x, y and z. Just go ahead and use the class for x, y and z. Then select all the code and hit Ctrl Enter, and you will see the full output in the console exactly as you can see here. The value of x is a complex number. This is the type for 2 plus 9i, and also 1 minus 4i is a complex number, and the last one z, the value of z 7i is a complex number. So we got complex, complex and complex in the console. This is the result here. And also you can type in the console x to get its value, y to get its value, and also z to get its value. As you can see, the value of the z variable equals 0 plus 7i. The real part equals 0 in this case, in this value. So we got 0 because we use 7i only as a value for the z variable. Thank you so much for watching. See you again next lesson. Hello and welcome to this lesson about type conversion in the R programming language. You can convert from one type to another for numbers. For example, you can use the as.numeric built-in function in R to convert to numerical values or numerics. Also, you can use the as.integer function. It's a built-in function to convert to integer numbers. And the last one we have is the complex built-in function, the as.complex built-in function to convert to complex numbers. If you have a numerical value and want to change it to a complex number, you can do that by using the as.complex built-in function in R, and I will show you all of that in action. First of all, let's use the function called as.numeric to convert from integer to numeric. As you can see in this example here, as.numeric function, we assign it to a variable called newNumeric for num3 to change the value of num3 from integer to numerical value or to numeric. And you can see after using the class built-in function for this new variable called numeric, we got this output. In this case, the type for this variable or the value of the num3 variable is changed from integer to numeric. So after using the class built-in function with the new numeric variable as a parameter for that function, and selecting all the code and hitting Ctrl Enter or using the run button to execute this code, we got numeric in the console, the type that the value of the new numeric variable belongs to. And you can type in the console new_numeric and hit enter to get the value of this variable, this new variable. The value of this variable now is numeric, is a numerical value. The value is changed from integer to numeric by using the as.numeric built-in function in R. And also you can see in the environment panel or the environment section here, we have the new numeric, the new variable, as you can see, and its type is numeric, not integer. The value of the num3 variable is changed from integer to numeric, and the new variable that is called new numeric is a numerical value, exactly as you can see here in the global environment section. The second example we are gonna take is to convert from numeric to integer by using the as.integer built-in function. Just create a variable and assign the as.integer built-in function to this variable, as in this example, and put a variable or numerical value as a parameter in between the round braces of that function. After selecting all the code, and you can see in the console, we got in this case integer, not numeric. You know, the oldest value for the num1 variable is a numerical value or numeric. And we use the as.integer built-in function to convert its type from numeric to integer, as in this example here. And after this statement, you need to use the class built-in function with the new variable as a parameter or as an argument for that function in between the round braces of the class built-in function to get the output or to get the type in the console. After selecting all the code and hitting or clicking Ctrl plus Enter or use the run button to show this output also in the console, you will get the output like that, integer in the console. The new value is integer, and you can see inside the global environment tab or section, the oldest value num1 is numeric, but the new value new_int is integer, as you can see in the environment section. And if you wanna get the value of the new int, the new variable in the console, type its name and hit enter, and you will get its value, as you can see, which is 12, not 12.9. The new value is integer. 12 is an integer number without any decimal point, but the oldest value, 12.9, was a numerical value, and we use the as.integer built-in function to change the value from numeric to integer. Now let's talk about the as.complex built-in function in the R programming language. Let's take an example to convert to complex. We are gonna convert an integer number of num3, the value of the num3 variable, from integer to complex by using the as.complex built-in function. As you can see, num3 as a parameter or as an argument for the as.complex built-in function, then the class built-in function to get the type, and you can see in the console after selecting all the code and hitting Ctrl Enter, you can see our output is complex. The value of the num3 variable is changed from integer to complex. This is the new type. Just you need to create a new variable and assign the as.complex built-in function to that variable. In between the round braces of that function, place the variable, the targeted variable, in this case is num3, to change the value of the num3 variable from 99 from integer to complex, and the class built-in function after that statement to get the new type in the console, to get the type of the new comp variable, the new variable in the console. And the new type, as you can see in the console after running this program, is complex. Now you can go to the console and type the new variable name to get its value if you wish. And you can take a look at the environment panel. You will see the new variable, new comp, and its type is complex. Its length equals 1, and the value of this variable is 99 plus 0i. In this case, the value of the num3 is changed from 99 to 99 plus 0i, as you can see, from integer number to complex number. In the console, type the variable name new underscore comp and hit enter, and you will get the new value for this variable. The value of this variable is a complex number, as you can see, 99 plus 0i. This number now has the imaginary term with the I symbol. Thank you so much for watching. See you again next lesson. In the R programming language, you can perform mathematical operations on values. Operations such as addition, subtraction, multiplication, division, and many more. Also, you can use many useful built-in functions to perform mathematical operations on values, like the max function to find the highest number or the largest number in a set of numbers. Also, you can use the min built-in function in R to find the lowest or the smallest number in a set of numbers or sequence of numbers. You can use the square root built-in function to get the square root of a number, and also the abs function to get the absolute value of a number. It's a built-in function also in R. The ceiling built-in function is used to round the number upwards to its nearest integer. You can use it to round any number. And the floor built-in function, unlike the ceiling built-in function, the floor built-in function is used to round a number downwards to its nearest integer. Let's see all of that in action. You can add two numbers together or more than two numbers by using the plus sign operator. This is a simple addition operation, as you can see, and by hitting Ctrl Enter or selecting this code and hit the run button, you will get the output in the console. The output from adding 11 to 23.5 equals 34.5, as you can see in the console. And also by using the minus sign operator, you can subtract two numbers or more than that by using the minus sign operator, like this example here, 111 minus 55, and the output, as you can see in the console, equals 56. This is the output from this subtraction operation. It's so easy to do in the R programming language. Just type the operation and hit Ctrl Enter on the same line, or you can select all the code and hit the run button to show the output in the console exactly as in this example. The asterisk symbol in R is used to multiply two numbers. As in this example here, 3 multiplied by 11, the output from this operation equals 33 in the console here. You can multiply two numbers or more than two numbers by using the same symbol, by using the asterisk symbol, as in this example here. Add and hit Ctrl Enter or use the run button to show the output in the console. And you can combine many mathematical operations on the same line in the same operation, like this example here. 100 minus 32 multiplied by 2. This is a really simple example, but you can combine subtraction, multiplication, division, and many more on the same line to get its output. and the output from this operation equals 36, as you can see in the console. Once you hit Ctrl Enter on the same line for this statement to get its output in the console, or you can select the code and hit the run button, or use Ctrl plus Enter to get this output in the console. If you wanna get the maximum number or the largest number in a set, use the max built-in function. As in this example here, the max built-in function to get the largest or the biggest number in this sequence. The biggest number equals 20. 20 is the largest number in this sequence here. We have the sequence inside the round braces of the max built-in function, or you can assign a sequence to a variable and use the variable name inside the round braces of the max built-in function to get the maximum or the largest number or the largest value in that sequence. And to get the minimum number in a set of numbers or in a sequence of numbers, you can use the min built-in function, as in this example here. The minimum number in this sequence equals 11. As you can see, this is the smallest number in this sequence in between the round braces of the min built-in function. Just call it only by using its name, and in between the round braces of that function you can insert sequence of numbers to get the minimum or the lowest value or the lowest number in that sequence. And you can run this statement by using Ctrl Enter or using the run button from the top side to show the output in the console. As in this example here, we got 11. To get the square root of a given number, you can use the square root built-in function. As you can see here, and in between the round braces, place a positive number to get the square root for that number. And if you try to set a negative number, you will get an error in the console. The square root for 20 equals 4.47, as you can see in the console. Let's try another one to get the square root for another number, for example 100. Hit Ctrl Enter and you will see the output in the console. The square root for 100 equals 10, as you can see. 10 multiplied by 10 equals 100. And as we said beforehand, you cannot use negative numbers as an argument for that function. Let's try with a negative number to show the output for this operation. For example, -16, and hit Ctrl Enter. As you can see, warning message. We have an error here. You cannot use negative numbers inside the round braces of the square root built-in function. Change it to positive and hit run again, and you can see we got the square root of 16, which is 4 in the output. As you can see, 4 multiplied by 4 equals 16. Also, to get the absolute value for a number, use the abs built-in function, as in this example here. The absolute value for that number, minus 13.5, equals 13.5. The abs built-in function is used to return the absolute value, and the absolute value for a number is a positive value, as in this example here. The positive value for minus 13.5 equals 13.5 without the minus sign operator. You can use the ceiling built-in function in the R programming language to round a number upwards to its nearest integer, as in this example here. The ceiling function in this example is used to round this number 3.3 upwards to its nearest integer, which is 4. Just call the ceiling function by using its name, and in between the round braces try to insert the number, as in this example here for 3.3. And after that you can hit Ctrl Enter to show the output in the console. However, if you want to round a number downwards to its nearest integer, you can use the floor built-in function for the same number here by using the floor built-in function with the same number 3.3. In this case we got 3, not 4. By using the ceiling built-in function, we got 4, and by using the floor built-in function downwards to the nearest integer for that number, 3.3 equals 3 in the console. By running this statement, you need to call that function also by using its name and place the number in between the round braces of that function and hit Ctrl Enter, or use the run button to show the output in the console as in this example. Thank you so much for watching. See you again next lesson. Hello and welcome to this lesson about character data type in the R programming language. A character or strings simply are used for storing sequence of characters or text. You can create a string data type in the R programming language or store it inside double quotes or single quotes. To create a string or character data type in R, just use double quotes and single quotes, and inside these double quotes place sequence of characters or text. This is a string data type. Also in R, you can assign a string to a variable. Just use the variable name, a descriptive variable name, and by using the assignment operator, assign a value to this variable, and this value will be a string or character data type, sequence of characters, by using double quotes or single quotes. It's available. Also, you can easily create multiple line string or text by using double quotes or single quotes. And in this course, I'll show you how to use a built-in function called the cat function. The cat function is a built-in function to get the same input string shape. If you create a string data type with multiple line and you want to print it as it is, just use that function called the cat function with the same input string shape. Also, there is a useful function we are gonna use in this course called the inchar function, or the number of characters function, to find the number of characters in a string or a character data type, or to find the length of that string. Another useful function is the grill built-in function, and you can use it to check if characters are present in a string or in a sequence of characters or not. And the output from using this function will be a logical value or a boolean value, true or false easily. If you have two strings or more and you want to concatenate these strings, you can do that. You can combine two strings by using the paste built-in function. Also, just use the paste built-in function and use the two strings or more than two strings as parameters in between the round braces of that function. Finally, I'll show you how to use escape characters like \n and also \, in the R programming language. And here you can see the important escape characters in R. The \, symbol is used to escape the inner double quote or single quote. To show a string \, or a \, in sequence of characters, use double \, like this character here. Also, you can use the \n to add new line, \r for carriage return, \t for adding tab, also \b to add backspace in a string data type or a character data type. The type of strings in R is character. You can create a string in the R programming language or a character data type by using double quotes, like this example here. We have this sequence inside double quotes or double quotation marks. Hello R. This is called a string or a character data type. Or you can create the same string by using single quotes as you wish, as in this example here. And you can run the two strings by using Ctrl Enter, or select all the code and hit Ctrl Enter, or use the run button to show the output in the console. As you can see, for the first character or the first string, we got hello R inside double quotes in the console, as you can see, And also for the second statement, hello R inside single quotes, we got in the output in the console the hello R sequence of characters in double quotes also in the output. You can do the same thing with double quotes or single quotes as you wish. And by using the two ways you will get the same output in the console. You can assign a string to a variable easily by using the assignment operator or the left arrow operator, as in this example here. The same previous character or the same previous string, the hello R string, as you can see as a value of this variable, we assign it to this new str variable. You need to run this statement and after that use the variable name to get its value, which is this message or this text or this string or this character data type, the hello R sequence of characters, as you can see. Let's use the variable name after running this statement in the console. Just use the variable name new str and hit enter and you will get the value that is stored inside this variable called new str. The value is this string data type or this character data type in R, the hello R message or the hello R character. And also you can do the same thing with single quotes. You can assign a string data type or a character data type to a variable by using single quotes to store a string. As in this example here, you will get the same previous result in the console. Type the variable name in the console after running this statement and you will get the same previous output, the hello R inside double quotes also in the output. In the console, type the new variable name new str1 and hit enter and you will get this output. As you can see, the same previous output, the hello R string or character data type in between double quotes in the console. Also, you can create multiple line string or character data type in the R programming language and you can assign it to a variable. Here in this example, we just created a variable called multi-line str and we set this string as a value of the multi-line str variable. This string, as you can see in multi-lines, hello, the R programming language is so powerful, R is fun. You can see this is a multi-line string data type in multiple lines. As you can see, you can create a multi-line string by using the same way and assign it to a variable. Then you can use the variable name to print out this string in the console. But there is an important point here, which is if you try to use the multi-line str variable by using its name to print out this string in the console, you will see that the R programming language will add a \n at the end of each line break. And this is called an escape character in R. Let's see that. Let's use the multi-line str variable name to print out this multi-line string in the console to show this output. After running the code, go ahead and type in the console the variable name multi-line str, and as you can see, this is our string, our collection of characters. But you can see at the end of each line there is \n. You can see this is called an escape character in R. Do you want to print the string as it is in the output? If you want to do that, you can use the cat function. The cat function is a built-in function to display the multi-line string as it is, or to display the code as it is in the output with the same shape in the input. Let's do that. Let's call the cat built-in function. After this statement, type cat, the cat built-in function, and insert multi-line str as a parameter for the cat function, and you can see the output after running this statement in the console here. We got hello, the R programming language is so powerful, R is fun, the same shape as in the input. We got our multi-line string as it is in the input. with the same shape as you can see in the console. Really very useful function. To get the length of any string in R, use the inchar built-in function or the number of characters built-in function. This inchar function, just insert the variable name that contains that string, and you can see the output from the multi-line str. As you can see for this string has 59 characters. This is the length of the multi-line string we have created called hello. The R programming language is so powerful. R is fun. This string has 59 characters. You can use the inchar character with any string to calculate the number of characters in that string. Let's try another example for using the inchar function. As you can see, for new str, and the number of characters in the new str string equals to 8, as you can see in the console. You can use the inchar function also, as we did previously with the multi-line str, and in between the round braces insert the name of the variable that stores this string, and you can see the output in the console after selecting the code and hitting Ctrl Enter or using the run button from the top side. Then you will get the output in the console, the number of characters in that string. To check if an item is present in a sequence of characters or in a string, you can use the grill built-in function. Call it only by using its name, as in this example here, and in between the round braces put the character, then put the variable name that stores your string or the string you wish, the targeted string. The output for this example, as you can see, is a logical value is true in the console because the character H is located in that string, in that multi-line string data type or character data type, the sequence. H is the first character in that string for hello. The output always for this operation will be a boolean value or a logical value. If this character is not present in this string, the output will be false instead of true. Let's try another one. We want to use the grill built-in function again to check if W is present in the multi-line str or not. In this case, we got false in the console, as you can see, as shown here in the console. A logical value or a boolean value also, because W is not present in this string. You can see, hello, the R programming language is so powerful, R is fun. There is no W here. There is no letter called W in this string. So the output for using this grill built-in function equals false in the console after running this statement. Now let's talk about the string combination or concatenation. You can merge or concatenate two strings by using the paste built-in function in R. Just create two strings, assign them to variables like this example here. Hi, my name is, assign it to str1, our programming language, and assign it to str2, and after that use the paste built-in function with the two parameters str1 and str2. Then you can run this program. You can select all the code and run this program, and you will get this output in the console as shown here. Hi, my name is our programming language. The two strings are concatenated and combined easily. Just call the paste built-in function, and in between the round braces of that function separate between the two variables using comma, str1 and str2, as you can see here in this example. In R strings, you cannot use double quotes inside double quotes without escaping the inner double quotes by using backslash. We have an example here. You can see in this example we have inner double quotes surrounded by outer double quotes, and to escape this without any errors, just use backslash before each double quote, each inner double quote inside this string. Let's do that. Go inside this string and put backslash before each double quote, as in this example here. Now no errors here. You can run this statement without any problems, without any errors, and you can get the value of the str2 in the console by typing its name, as in this example here. Type str2 and hit enter, and you will get this output R, then backslash programming, then backslash, then language, without any errors. And as you know previously, if you want to print out this string as it is with the same shape in the input, just use the cat built-in function. Let's use the cat built-in function with the str2. Go ahead and type cat after str2, and inside the round braces of that function insert the variable name and hit enter, and you can see the output as it is. R, and the programming inside double quotes without any errors here, then language. The cat function is really very powerful function in the R programming language. Finally, you can use the backslash n to add new line or to add line break. We use it in this string called str2. Select all the code, and after running this program, you can see in the console here R programming, then language is placed on the next line by using the backslash n. That's it, easily, the backslash n to add new line or line break in string. Also you can use backslash t to add tab, and backslash b to add backspace in a string. Thank you so much for watching. See you again next lesson. Hello and welcome to this lesson about booleans or logical values in the R programming language. Booleans or logical values represent by one of two values, true or false. Boolean values or logical values in the R programming language are used in the conditional if statement conditions or test expressions. Also, the answer from any comparison operation is a Boolean value or a logical value, true or false, and you can assign true or false to a variable by using the assignment operators available in the R programming language, and you can create sequence of Boolean values using different data structures in the R programming language. In the conditional if statement, if the test expression or the condition is true, the program will execute the body or the full code of the conditional if statement, and if the condition or the test expression for that conditional statement is false, the program will skip the body or the condition of this conditional statement simply and easily. Our first example here, 13 is less than or smaller than 3. The output from this operation is false because 13 is greater than 3. The output, as you can see in the console, is a logical value or a Boolean value, false. And if this statement is true, the program will give you true after running the statement directly in the console. Let's take another one to make everything clear to understand. The second example is 12 equals to 12. The output now is true Boolean value. If you run this statement by hitting Ctrl Enter, you will get this output as shown here in the console. We got true because the statement is true, a Boolean value or a logical value, as you can see from this comparison operation also. Let's try another one. Type 12 equals to 10, for example. In this case, we got false in the console here. This program shows this output in the console after hitting Ctrl Enter or using the run button to run this statement. because this statement is false. The result from this comparison operation is false, so the output is this logical value or this Boolean value in the console also. Let's take another example. 20 is greater than 19. The result from this example here, as you can see, is true because the value 20 is greater than the value 19. You know that. The output is true. You can try this by yourself with different values to show the output in the console, to show the logical values in the console from any comparison operation like we did here with these examples. Also, you can use the comparison operators to compare between variables. Create two variables, x and y. The value of x equals 20 and the value of y is 10, and after that select all the code or these two statements and hit Ctrl Enter, or use the run button to run these statements, and after that you can see in the global environment or in the environment panel we have the x and the y variables here. Now after that you can use them inside the console with the comparison operators. You can compare between them. You can compare between x and y by using any comparison operator. In the console, type x is less than y, hit enter, and you will get false. The value of x is not less than the value of y. 20 is not less than 10, so the program will give you this logical value in the console false as an output. Let's try another one with the two variables also x and y. Type x is greater than y and hit enter. As you can see now the output is true. 20 is greater than y actually. So the output in this example is this Boolean value true. X equals to y. This is false, completely false. Simply the value of x not equals to the value of y. 20 not equals to 10. So we got false in this case. Try by yourself to use the comparison operators to compare between values and see the output in the console as we did here in this lesson. Thank you so much for watching. See you again next lesson. There are different types of operators in the R programming language to perform operations on variables and values. The first type of operators is called the arithmetic operators, like the plus sign operator for addition, minus sign for subtraction, the asterisk operator for the multiplication operations, and also division, exponents or exponentiation operation, floor division, and also integer division. The second type is called the assignment operators to assign values to variables in the R programming language. The third type of operators is called the comparison operators to perform comparison operations in the conditions of the conditional statements in the R programming language, and also you can use these comparison operators in the test expressions of loops and many more, like smaller than, greater than, smaller than or equal to, and so on. And I'll show you all of that in action one by one. The next type is called the logical operators in R. Logical operators simply are used to combine conditional statements, like the AND operator. First of all, the element-wise logical AND operator, then the logical AND operator, then the OR operator, and after that the NOT operator, the logical NOT operator, to return false if statement is true. Let's create two variables to perform arithmetic operators in these values for these two variables, x and the value of x is equal to 12. We assign 12 to x, and also we assign 10 to y. You can use the arithmetic operators to perform mathematical or arithmetic operations on these values here by using the variable names. You can use the plus sign operator or the addition operation to add x to y, to add the value of x to the value of y. The value of x plus the value of y equals to this number in the console, 22. 12 plus 10 equals to 22. Let's perform the subtraction operation also by using the minus sign operator for these values. On these values here, 12 and 10. 12 minus 10 equals to this number 2, as you can see. Put the variable name x, then the minus sign operator, then the next variable y in this case. Next, the multiplication operation by using the asterisk symbol. As you can see, x multiplied by y. Run this statement and you will get this output, 120. This is due to multiplying 12 by 10. And you will get this output or this result in the console. For the division operation, you can use the slash symbol, x divided by y. And the output after running this statement, as you can see, 1.2. The output from this operation is not integer number. For exponents in R, you can use the caret symbol to perform the exponentiation operation, exactly as in this example here. X to the power of 2 equals to 144, as you can see in the console. 12 to the power of 2 equals to 144. That's it, easily. Try to do the same thing with the value of y variable. To get the remainder from any division operation in the R programming language, use double percentage sign or double remainder operator, as in this example here. The remainder from dividing x or the value of x by 2 equals to 0. There is no remainder here. The remainder equals to 0. Try to do this by yourself also. Try to change 2 to another number and see the differences in the output. If you want to divide two numbers in the R programming language and get an integer number in the result, you can use the integer division operator, like this example here. X, then the integer division operator, and after that y, to divide the value of x by the value of y. And you can see in the output is integer number 1, not 1.2 as in the normal division. Now let's discuss the assignment operators in the R programming language. In R, we use the left arrow operator to assign a value to a variable, like this example here. The assignment operator is the left arrow operator to assign 5 to this variable called new num. And if you type new num in the console, you will get its value 5. 5 is stored inside this variable called new num by using this assignment operator. Also, you can use the global assigner to assign a value to a variable. As you can see, this is called the global assignment operator to assign 10 to new num. And you can see in the console the new value for the new num variable equals to 10 in this case by using this global assignment operator, double less than in the left arrow operator, as you can see. If you have a function and a variable inside that function in the local scope of that function you create, you can use this assignment operator, this global assignment operator, to assign a value to a variable to make it works globally instead of locally inside the function only. You can make it works globally outside that function also by using this assignment operator. Also, if you wish, you can change the direction of the assignment operator, as you can see in this example here, but this is not common. And the new value for the new num variable in this case, as you can see, equals to 11 by using this new direction for the assignment operator. And you can do the same thing with the global assignment operator. You can change its direction, as you can see in this example, and the new value for the new num variable becomes this number here in the console, 12. This is the new value for the new num variable. Let's talk about the comparison operators in the R programming language. But first, after this comment for comparison operators, let's create two variables to work on these variables in the comparison operations. We have x and its value is 10, and also we have the y variable and its value is 12. Let's use all the comparison operators available in the R programming language. For example, greater than, smaller than or less than, greater than or equal to, smaller than or less than or equal to, is equal to, and also not equal to. And select all these statements, and you need to hit Ctrl Enter or use the run button to execute all these statements. You will get the output for each operation from these operations, and the output will be a logical value, true or false. X greater than y is greater than y. The output for this operation is false. 10 is not greater than 12. X is smaller than y. The output is true, and so on. Let's run this program by hitting Ctrl Enter. Once you run this program, you can see all the results in the console here. X is greater than y is false, x is less than y is true, x is greater than or equal to y is false, x is smaller than or equal to y is true, x equals to y is false, x not equals y is true, as you can see. Okay, now let's talk about the logical operators available in the R programming language. Let's use the element-wise logical AND operator, logical AND operator, element-wise logical OR operator, and also the logical OR operator, and you can use the logical NOT operator if you wish. First of all, the element-wise logical AND operator. It will give you true if both elements are true. If all the terms of this logical operator are true, then the program will give you true. As in this example here, the two sides of this element-wise logical AND operator are true, so the output is true in this example. Let's try another one. If you try to change one of the two terms to false, the program will give you false. It must be true for the two sides to get true in the console or in the output in general for the element-wise AND operator. Another example for the logical AND operator. Also, the logical AND operator will give you true if both statements or the two terms of the logical AND operator are true. It will give you true. In this example here, the right side or the right term of the AND operator is false, so in this case the program will give you false in the console, as in this example. The two sides must be true of the logical AND operator. You can change the right side of the AND operator from false to true to get true in the output, to get the logical true output in the console. As you can see in this example, the output now is true, not false, because the two terms are true for the logical AND operator in this example. Let's take another example, but in this case with the element-wise logical OR operator in R. As you can see, true or false, the program will give you true. The program in this case will return true if one of the statements of the OR operator of the element wise OR operator is true. You can see the left side is true, so the program will give you true. If also the right side is true, the program will give you true. In this example, we use the element-wise OR operator in OR by using the pipe symbol. You can try to use the OR operator by using double pipe symbol, and it will return true also if one of the statement is true. If one of the two sides of the OR operator is true, the program will give you true. And the last example for the NOT operator. You can use the logical NOT operator to return false if statement is true. And we have a simple example here. True equals not false. The program in this case prints true in the output because true actually equals to not false, because not false equals to true. That's it, easily. You can use the NOT operator to return false if statement is true and vice versa. Thank you so much for watching. See you again next lesson. Hello and welcome to this lesson about vectors in the R programming language. What is the definition of a vector? A vector is just a list of items that are of the same data type. You can use the C built-in function in the R programming language to combine the list of items to a vector. To create a vector, just use the C built-in function and separate the items inside the round braces of that function by using comma. And we have a simple example here. We have this vector of strings to combine these strings together, and this is called a vector by using the C built-in function. The first item in this vector is London, the second item is Cairo, and the last item is Berlin. And we separate between the items using comma, as you can see inside the round braces of the C built-in function. Assign it to a special variable and try to make this variable a meaningful variable that describes its value. And this special variable is the vector name in this example here. This vector name is called cities. Let's see in action how to work with vectors in the R programming language, and also how to use many useful functions to work with these vectors. We will create two different vectors called countries and fruits. The first vector is called countries, and as you can see, the C built-in function call it only, and we assign it to a special variable called countries by using the assignment operator. You can see all the items inside the round braces of the C built-in function. Go ahead to create the second one, which is fruits, and also we are gonna use the C built-in function to assign values, many values in between the round braces of the C built-in function also. This is our second vector. After creating these two variables, you can select all of them and hit Ctrl Enter. You can see in the environment tab or panel, you can see countries is created and stored in the memory, then fruits. And let's take a look at the countries vector. The first item is Egypt, the second item is Germany, the third item is England, the fourth item is USA, and the last item in this vector is Japan, all that inside the round braces of the C built-in function, and this is called a vector of strings. Separate the items, separate between the items using comma, as in this example, and the same thing for the second one, which is called fruits. The second vector is called fruits, and the first item in the second vector is apple, the second item is banana, and the last item is cherry. You can add more than that. You can add many items as you wish in between the round braces. And if you want to print these two vectors on the screen through the integrated terminal. Use the variable names, countries and fruits, and select all the code. You can hit Ctrl Enter, and you can see in the console we got the countries vector, and also after that the fruits vector. After running this program easily, you can run it by using Ctrl Enter, or you can use the run button from the top side. We have created two vectors of the same data type, strings. Now let's create a vector of numerical data types or numerical values. You can do that also by using the same method. Use the C built-in function and assign it to this special variable called new numbers. Put 10, 20, 30 and 40 inside the round braces, and you can use the variable name. Select all the code, hit Ctrl Enter, and you can see in the console this is our output. This is our vector here in the console. We got 10, 20, 30 and 40 one by one. This is the vector we just created. All the values are numerical values. And also to print out this vector in the console, we just use the variable name, the special name new numbers. You can give it any name you wish, any special name you wish, and use that name, that special name, to print the result in the console like this example here. If you want to create a sequence of numerical values, you can use also the colon operator. You can use the colon operator simply to create a vector with a numerical value in a sequence or in a collection. And we have an example here. We have a range from 10 to 20. This is our sequence of numerical values. 10 is included and also 20 is included, as you can see in the output here in the console. You can use the colon operator to display range or sequence of numerical values like this example. Assign it to a special variable and use the name of that variable to print the result in the console. Select all the code and hit Ctrl Enter to show the output in the console, as in this example here, the sequence or collection from 10 to 20, and the first number in the range is included 10, and the last number or the end point 20 is included also in this range. Also, you can use the same technique to create a vector or a sequence of numerical values. You can create a vector of numerical decimal values easily with a decimal point for each number. Let's see that. Just create a new variable, and this variable is called sequence1, and assign the range to it 2.5 to 7.5, and use the variable name after that. Select all the code and hit Ctrl Enter, and you will get the sequence. This is a vector, another vector with decimal points, as you can see, for each number for this sequence easily. And there is an important point here, which is if the last item or the last element in this sequence doesn't belong to the sequence, the program in this case will not show it in the output in the console. Let's change the endpoint here in this sequence, this vector, from 7.5 to 7.4 for example, and the last item or the last element in this case, the endpoint, doesn't belong to the sequence. So once you run the program, you cannot see 7.4 in the output here, because this element doesn't belong to this sequence or this vector. Another useful example, let's create a vector of logical values or Boolean values, true and false. Called it logics, and assign the C built-in function to logics, false, true, true, false. These are the four values in this vector called logics, and you can see this is the output for this operation. All the values inside this vector of the same type, Boolean values or logical values, as you can see, true and false. After creating a vector, if you want to display the number of items that this vector has, you can display this length by using the length built-in function. Just call it only by using its name, and in between the round braces insert the vector name, for example sequence1, and you can hit Ctrl Enter, and you can see inside the sequence1 vector there are 5 items or 5 elements. This is the length of the sequence1, or the amount of elements or values in this vector easily. You can do the same thing with any sequence or with any vector you created. You can use the length built-in function to get the number of items in a vector by using its name, and place this vector as a parameter or as an argument in between the round braces of this built-in function. Then you can select the statement and run it to show the output in the console as in this example. Let's try another one. Let's use the length built-in function with the logix vector, for example, to get the number of items in this vector. Now you can see this vector has 4 items here: false, true, true, and false. You can use the sort built-in function in the R programming language for sorting vectors alphabetically or numerically, from A to B to C to D and so on. Or you can sort the vector numerically from 1 to 2 to 3 and so on. Exactly as in this example here, we use the sort built-in function with the countries vector to sort all the values in this countries vector alphabetically, because all the types in this vector are strings, you can see. And you can take a look at the output in the console. You can see the first letter for each word: E, then G, then J, then U. All the items in the countries vector are sorted alphabetically based on the first character, as you can see, or the first letter for each word. Let's try another one to sort a vector numerically in this case. For example, for the new numbers vector we created previously, and you can see in this case all the items are sorted numerically in this case, because all the values of the new numbers vector are numerical values. So if you have a random vector of numerical values, you can use the sort built-in function to sort all the values one by one by using numerical sorting. Vector items are indexed and ordered, so if you want to access any item from a vector, you can use the index number for that item. The index number for the first item is 1, and for the second item is 2, and so on. If you want to access any item, use the name of the vector followed by square brackets, and in between these square brackets place the index number for that item, like this example here. To access the first item from the fruits vector and the second item also from the fruits vector, we use fruits1 inside square brackets, then fruits, then square brackets, and we place 2. And after that, select all the code and run the program in the terminal, in the console, by using Ctrl Enter or by using the run button, and you will get this output in the console here. The first item that has the index 1 is apple, and the item in the index 2 is banana in the fruits vector easily. You can display or access the last item or the third item from the fruits vector by using the index 3. Try to access the third item in this list by using the index 3, by using the same method or the same technique. The vector name followed by square brackets and the index number for that item inside these square brackets, and run the program after that to show the output in the console. Also, by using the index numbers, You can access multiple items or elements by referring to different index positions with the cbuilt-in function. In this example here we have the index 1 and the index 3. To access the first item that has the index 1 and the third item that has the index 3, all that inside the round braces of the cbuilt-in function inside square brackets after the name of the vector we just created called fruits, and you can see the output in the console without any complication. We got the first item in the fruits vector, apple, and the third item that has the index of 3, cherry, from the fruits vector also. Negative indexing in the R programming language is used if you want to access all the elements from a vector except the ones specified. As in this example here, we want to access all the items from the fruits vector instead of the first item, except the first item of this fruits vector. And you can see all the items in the console here except the first item that has the index 1. So put the minus sign operator before the index number as in this example here to get all the items except that index number or that item. Also, if you have an existing vector and you want to change the value of a specified item, you can do that by using the index number for that item. Use the variable name or the vector name followed by square brackets with the index number inside square brackets and assign the new value to this special name or this variable with the index number. In this example here, we want to change the value of the second item in the fruits vector to fig. We want to change it from banana to fig. So hit Ctrl Enter, and after that you can type fruits in the console and you will get the fruits vector with the new item. As you can see, the second item is fig now. The second item is changed from banana to fig. You can repeat vectors in the R programming language by using the rep built-in function. Assign it to a variable, and in between the round braces of that function you can insert a vector, and you can use each parameter to repeat it. For example, in this case twice by using 2, or you can repeat it any number of times you wish. Select all the code and you can see our vector here, our numerical vector, is repeated. Each item in the repeated vector is repeated twice: 10, 10, 20, 20, 30, 30, 40, and 40. And you can replace the value of each parameter, or you can change the value of each parameter or each argument in between the round braces of the rep function from 2 to 3 to 4, or any number of times you wish. For instance, let's change the value of each parameter to 3 and select all the code and run the program again by using Ctrl Enter. You can see 10 is printed 3 times for 3 times, 10, 10, 10, then 20, 20, 20, then 30, 30, 30, and after that 40, 40, 40. In this case, each item or each value in the repeated vector is repeated for 3 times. Also, you can specify the number of times for repeating for each item in a vector. In other words, you can repeat each element in that vector independently here. You can see 2 for 10, 3 for 20, 4 for 30, and 5 times for 40 by using the times parameter inside the round braces of the rep function. You can see the times parameter is the second parameter or the second argument inside the round braces of that function. After our vector here, we set 2 to display 10 for twice, 3 for 20, 4 for 30, and 5 for 40. And you can see the output for this repetition in the console after running this program. 10 is printed 2 times, 20 3 times, 30 4 times, and 40 5 times, as you can see here in the console. In R, if you want to create sequence of numbers in a vector, or if you want to create a vector with numerical values in a sequence, you can use a very useful built-in function called seq function, and this function to make bigger or smaller steps in a sequence, simply to create a vector of numerical values also by using 3 parameters from, to, and by. And we have an example here by using the seq built-in function with the from parameter, to parameter, and also the by parameter. This sequence from 1 to 50, and the incrementation by 5 in this example. By is the interval of the sequence here. 50 is not included in the output here. If you want to add 5 after 46 to this number 46, this will give you 51, not 50. So 50 is not included in this sequence. You can start from 0, put the value of the from parameter 0 instead of 1 to include 50. To start from 0, then 5, then 10, then 15, and so on, until reaching the last one, which is 50. Go ahead and change this value to 0 and run the program again, and you can see this is our sequence: 0, then 5, then 10, then 15, then 20, then 25, until reaching the last item, which is equal to 50. And you can notice that 50 is included here in the sequence. Thank you so much for watching. See you again next lesson. Hello and welcome to this lesson about lists in the R programming language. What is a list? A list is a sequence of data types or a collection of values. You can store different data types in the same list. Also, list items are ordered and changeable, so after creating a list, you can change any item from that list easily. And you can access any item by using the index numbers. By using index numbers for this list, you can access any item. For example, the first item has the index to access the first item, and to access the second item, you can use the index number 2, and so on. The first item in a list has the index number 1. And also, to create a list in the R programming language, use the list built-in function. This is so easy to do. Just call the list built-in function and place sequence of items or collection of values or different values, but try to make the values of the same type. Try to make all the values from the same type. This will make your code more organized, meaningful, and also understandable, like list of numbers, list of fruits, list of cars, and so on. And inside the round braces of the list built-in function, separate the items by using comma. Put the first item, then comma, the second item, then comma, and so on. And we have an example here. This list called fruits, special variable name. This is our list name, and we assign the list built-in function to this fruits special variable, to this fruits variable. And after that, you can see inside the round braces of the list built-in function, the first item is called fig, string data type or a character data type, cherry, the second item that has the index of 2, then the last item, lemon. We separate all the items using comma, as you can see. And if you want to print out this list on the screen, you can use the variable name called fruits. In this case, use the special variable name, and after that you can select all the code inside the RStudio and hit Ctrl Enter or use the Run button to show the output in the console. Let's see all of that in action. Let's create our list of characters or fruits by using the list built-in function. Call it fruits. This is a special variable and assign the list built-in function to this variable. And insert all the items inside the round braces of the list built-in function: apple, cherry, lemon, and the last item fig. This is a list of 4 items, as you can see, of characters or strings. You need to use the variable name like that, and you will see the output on the screen in the console. As you can see, once you hit Ctrl Enter, select all the code and run the program by using the Run button. And you can use also Ctrl Enter to show this output in the console. The first item that has the index 1 is apple. The second item that has the index 2 is cherry. The third item that has the index 3 is lemon. And the last item in this list that has the index of 4 is equal to fig. As you can see, this is a list of strings or a list of characters. Just call the list built-in function. You don't need to design that function from the ground up, because this function is a built-in function. By using the assignment operator, you can use or assign this function to a special variable and try to make this variable meaningful and descriptive that describes its value. Fruits and a list of fruits. And after that, use the name of the variable like this example to print the full list on the screen through the console, as in this example here. All the fruits are printed in the console from apple to fig. You can access any item from this list by using the index number for that item or that value. Let's see that. After this comment, accessing elements from a list, use the name of the variable or the list fruits followed by square brackets, then the index number inside these square brackets. In this case, we want to access the first item and the second item. The first item that has the index 1 is apple, as you can see in the console, and the second item that has the index 2 is equal to cherry. This is the value that has the index 2. And if you want to print out the index or the third item from the fruits list, you can use the index 3 and so on. Try to print out the third item and the fourth item from the same list called the fruits. This is the easiest way to access any item from a list by using the index numbers in between square brackets after the list name. Also, by using the index numbers, you can change the value of any item after creating it. If you have an existing list, you can change any value from that list by using the index numbers or by using the index number for that item you want to change. For example, here we want to change the value of the second item to watermelon instead of cherry. And after changing the value of the second item, you can use the variable name or the list name again to show the difference in the output. As you can see, the second item is changed from cherry to watermelon. Now the second value in this list is equal to watermelon, not cherry. Use the variable name or the list name followed by square brackets and insert the index number for that item that we want to change. And after that, you can use the assignment operator to assign new value to this variable or to this item easily, like we did here for the second item. You can do the same thing for the third item if you want. Change the value of lemon to any new value if you wish. If you want to know the length of any list or the number of items that any list has, you can use the length built-in function to do this job. You can use the length built-in function, and in between the round braces of that function, you can place the list name as a parameter or as an argument for this function, as in this example here. And in this case, this list called fruits has 4 items. You can use the length built-in function with any list. It's a very useful function to get the length or the number of list items easily. We have 4 items in the fruits list we created previously. To check if an item exists in a list or not, you can use the in operator in between 2 reminders. This is to check if an item is present in the fruits list or not, like mango in this case, followed by the checking operator, followed by the list name, and the same thing for apple. The output for this operation will be a logical value, true or false. Mango is not inside the fruits list, so we got false in this case. And for apple, we got true because we have an item called apple. We have this value inside the fruits list. So you can check if any item is present in the fruits list or not by using the same way, by using this checking operator, the in operator in between 2 reminders or 2 percentage sign, as you can see easily. This is the easiest way to check if an item is present in a list or not. Assume that we have a list and we want to add a new item or a new value to the end of this list. You can use the append function to do this job, to add new item or a new value to the end of any list, any existing list. You can use the append function. It's a built-in function and is used to append any item to the end of any list. We have the numbers list here and the append function to append a new item, for example 6, to the numbers list. As you can see, 6 is appended easily. 6 is added to the end of the numbers list by using the append built-in function. Try to create any new list, and after that, after creating that list by using the list built-in function, try to use or call the append built-in function to add a new item to the end of that list. And you can see in this example here, the append built-in function has 2 arguments or 2 parameters. The first parameter is the existing list that we want to append this item to it or at the end of this list. And the second parameter after comma is the new value that we want to add. We want to add 6 to this list called numbers, and after running this program, after selecting all the code and running the program by using the run button, we got this output here in the console. This list with the last item we just added 6 that has the index of 6 easily, as you can see. And also you can use the append function to add a new item to a specified position, and to add an item to the right of a specified index you can use the after parameter, as in this example here. In this example, and by using the append function, we have added 6 after the index 3 in the numbers list easily, and you can see now 6 is added at the index 4. In other words, you can say that 6 is added to the right of the index 3 in this example here in this numbers list. And you can do the same thing to add a new item in a specified position by using the same way. The append built-in function, call it only, use the list name, the existing list name, as a first parameter or first argument for this append built-in function, then the new value, then the after parameter to specify the position of this new value in the numbers list or any existing list you use. If you have an existing list and you want to remove an item from that list, you can use the index numbers also to do that. You can use the index number and use the minus sign before that index number to remove a specified item. Let's create a new list called new numbers, and after that let's remove the first item from that list by using the minus sign before the index number. After this new numbers list, let's create a new variable called new numbers 1 and assign the new numbers with the index number inside square brackets and minus sign before that number to this special variable called new numbers 1. And you can see by using this statement new numbers minus 1, the program will remove the first item that has the index 1 from that list called new numbers. As you can see here, 11.5 is removed from that list, the first item from the new numbers list. You can do the same thing with the index 2 with the second item, or the index 3 the third item, and so on. Create a new variable and assign the list name with the index number and put the minus sign operator before this index number inside square brackets to a special variable, this new special variable. And after that you can use the new variable name like new numbers 1 in this case and select all the code. You can run it after that and you will get the output on the screen. You will see the item will be removed from the output in the console. To clarify everything, let's remove the second item from that list called new numbers by using the index 2 after the minus sign, and select all the code and hit Ctrl Enter to run the program in the console. And you can see the second item 12.5 is removed from this list by using new numbers minus 2 inside square brackets easily. You can do the same thing for the third item if you wish. Do you want to concatenate two lists or more than two lists in the R programming language? You can do that easily, and the most common way to do that is the cbuilt-in function in the R programming language. You can use the cbuilt-in function to combine or join two lists or more than two lists if you wish. We have the cbuilt-in function here, and the first parameter is a list we created previously, and the second parameter is also another list. We want to combine these two lists, numbers and new numbers, by using the cbuilt-in function. After selecting all the code, you will see these lists are combined easily by using the cbuilt-in function. Just place the cbuilt-in function by calling it and assign it to a new variable and use the lists as parameters or arguments for the cbuilt-in function, like numbers and new numbers in this example. And also you can use the variable name after that, the new variable name, new list for example, and select all the code, and you can hit Ctrl Enter to show the combination in the output in the console. So easy and so simple, as you can see, by using the cbuilt-in function. And this is the most common way to combine two elements together or two lists together. And to print the output or the result for this combination in the console, use the special variable name as in this example here. Go to the environment section and select the search button for this variable called new list, and you can see more information about this new list called new list. All the information, the name, the index numbers, the type for all the values in this list, and also the value itself, as you can see. Thank you so much for watching. See you again next lesson. Hello and welcome to this lesson about matrices in the R programming language. What is the definition of a matrix in general? A matrix simply is a two-dimensional dataset with columns and rows. Also, you can say that it's an MN array with similar data type. You can create a matrix in the R programming language by using a vector input. Also, it has a fixed number of rows and columns. And you can also perform many mathematical or arithmetic operations on matrix in the R programming language. like addition, subtraction, multiplication, divisions, and more. And to create a matrix in the R programming language, you need to use the matrix built-in function. This function is used to create matrix with the two parameters in row and in column. In row to specify the number of rows, and in col parameter is used to specify the number of columns in this matrix. And I'll show you all of that practically. Let's get started. Let's create our first matrix called new matrix and assign the matrix built-in function to this new matrix special variable. And as you can see here, this matrix is created using a vector input by using the C built-in function, and in between the round braces of this C built-in function 10, 20, 30, 40, 50 and 60, you can see. And the in row parameter to specify the number of rows, and also the in col parameter to specify the number of columns. This matrix, as you can see in the output in the console after running this program, has 3 rows and also 2 columns by using the in row and the in col parameters inside the round braces of the matrix built-in function. And to print out the output, or to print out this new matrix on the screen, just use its name after initializing it, like this example here, new matrix, and select all the code, and you will get this output after hitting Ctrl Enter or using the run button from the top side. You will get this matrix called new matrix in the console, exactly as you can see here. You can do that. You can do this by yourself, and you can initialize many values, not only these 6 values here in this vector we created. The first parameter is a vector, the second parameter is the in row argument or parameter, the third parameter is the in col parameter to specify the number of columns here for this matrix. The C built-in function here in this example is used to concatenate or combine items together. This is a matrix of numbers, and also you can create a matrix, another matrix of strings or with characters. Let me show you that. Just place a comment matrix of characters, and after that call this matrix new matrix also, and assign the matrix built-in function to the special variable with the vector of strings, and also after that the in row and in column parameters to specify the number of rows and the number of columns. The first item, as you can see, London, then Oxford, then Cairo, then Austin, as you can see. And after that you can specify the number of rows using the in row, and specify the number of columns using in col parameter. The in row parameter is equal to 2 rows inside this matrix, and also 2 columns for this matrix. You need to use the variable name to print out this output in the console here. You can see in this case the first column London, then Oxford, the second column Cairo, then Austin, the first row London, Cairo, the second row Oxford and Austin. That's it, easily. You can access the matrix items easily if you wish by using square brackets and place the index of row and also the index of column in between these square brackets, and separate between them using comma. Just specify the row position, and after that specify also the column position. From the new matrix we just created, we want to access an item from row 1 and column 2, and this item is Cairo. As you can see, you can take a look at this matrix called new matrix, and you will see the Cairo item is placed in the row 1 in this position and in the column 2. And you can use the same technique to access any item from any matrix you created. Just use the matrix name, the special name for that matrix, or the variable name that contains this matrix, and after that square brackets, and inside the square brackets specify the row position for that item and also its column position. The first row has the index of 1, the second row has the index of 2, and so on. Also for columns, the first column has the index of 1, the second column has the index of 2, and so on. From the same matrix, let's access another item. For example, from the row 2 and column 2, this item, as you can see in this position in the row 2 and column 2, is Austin in this case. Also, you can access the for row by using the row index number or the row position only, then come after that. Exactly as in this example here, after new matrix, square brackets, then 2, and after 2, after the index number for the second row, comma. And you don't need to specify the number of columns here because we want to access the second row only, and the second row in the new matrix has these two values, Oxford and Austin. Let's access the first row that has the index 1, hit enter. As you can see, the first row in the new matrix has these two items, London and Cairo. Also, you can access columns. You can do the same thing with columns, just place comma, then the column position 2, for example. As you can see here, this is to access the second column from the new matrix, and the second column has these two values, Cairo then Austin. That's it, easily. Let's access the first column that has the index of 1. As you can see, the first column in the new matrix has these two values, London and Oxford. By using the cbuilt-in function, you can access more than one row if you want to do that from a matrix. Let's do that. New matrix, and after setting the name of the matrix, put square brackets, and inside these square brackets set the cbuilt-in function, and you can see inside the cbuilt-in function the row 1 and the row 2, and comma after that, after the cbuilt-in function, to access the first row and the second row from the new matrix easily, and you will see the output on the screen after hitting enter in the console simply. And you can do the same thing with columns. You can use the cbuilt-in function after comma inside square brackets of the new matrix in this example to access more than one column from the new matrix. Let's do that with columns also. Use the previous statement and place the comma before the cbuilt-in function to specify or to show the column 1 and the column 2 from the matrix called new matrix. Comma after the cbuilt-in function, this is to print out rows. Comma before the cbuilt-in function to print out columns. That's it, easily. After the matrix name, put square brackets, and you can show rows, you can show columns easily by using the index numbers for these columns or these rows, exactly as in these examples. Do you want to add additional columns or another column for this new matrix or any matrix you created? To do that, use the cbind function. The cbind function is used to add additional columns in a matrix easily. For the new matrix, we are gonna add another item by using the cbind function. Assign the cbind function to a new variable called another matrix or any new variable. The first parameter is our matrix, our existing matrix, new matrix, and we want to add this new item by using the cbuilt-in function, by using this vector to add a new column to the new matrix. In between the round braces of the cbuilt-in function, place two new items, Dubai and Tokyo, for example. Here After that, you need to use the variable name, another matrix, and run the program, and you will see the new column is placed in the new matrix simply, and you can see the third column now has Dubai and Tokyo. Just assign the cbint function to a new variable, a new special variable, name it anything you wish, any valid name in the R programming language, and put two parameters for the cbint function. Use these two arguments. The first one is the name of an existing matrix, and the second one is the cbuilt-in function to add new items to the new column using this vector Dubai and Tokyo in this example here. And after that, after initializing this statement, we use the variable name or the new matrix name called another matrix to show this output, or to print out this new matrix called another matrix. And this new matrix has Dubai and Tokyo, has the third column we just added by using the cbint function. You can do this also by yourself. It's so easy, as you can see. And you can do the same thing for rows. You can add new rows to this new matrix we created previously by using the rbind function. The rbind function in the R programming language is used to add additional rows in a matrix easily. Let's do that. After replacing this new comment, adding rows, you can use the new matrix, and you can use the rbind function after that to add a new row, and this new row has these two values, city1 and city2, and you need to use the new variable name add row for the rbind function to show the output, or to print out the output in the console exactly as you can see here. This new row that has city1 and city2 is added to the new matrix, and we assign this new array to a new variable called add row to this new variable. And to print out the new matrix on the screen with the new row, use the new variable name add row. You can assign it to any variable you wish. Just use the rbind function and place the two parameters or two arguments in between the round braces of the calling of the rbind function. The first one is the matrix, or is the existing matrix we have. The second one is the vector to add a new row. You can add more than one row if you wish by using the cbuilt-in function. We just added city1 and city2 here. That's it, easily. Also, there is an important point here, which is the cells in the new row must be of the same length as the existing matrix. You can use the cbuilt-in function in the R programming language to remove rows and columns if you wish. Inside square brackets, after the matrix name, just use this function with the position of row and the position of column. Let me show you that. Just create new variable. You can name it any name you wish, any valid name, and assign the new matrix to this new variable called new matrix. And inside these square brackets, after the matrix name we have, you can use the minus sign before the cbuilt-in function twice for the position of row and also the position of the column. This statement removes the first row and the first column from the new matrix, and if you try to print out this matrix or this new variable after this removing, you will get in the console the existing items in this matrix easily. The first row and the first column are removed from this new matrix by using our statement here, new matrix, and in between square brackets minus c1 for rows to delete the first row. Then to delete the first column, use minus c1 after this comma inside the square brackets of the new matrix or any matrix you created. Now we want to check if an item exists in the new matrix or not. And to find out if a specified item is present in a matrix like this new matrix here, just use the in operator in between two reminders, as in this example here, Cairo in new matrix. The program will give you true or false. However, we got true in this example here because Cairo is inside the new matrix, so the program will give you true. The output from this operation always is a Boolean value or a logical value, true or false. Let's try another one, for example Dubai, and in this case you will get false in the output in the console because Dubai is not inside the new matrix. As you can see, we got false, also logical value or Boolean value. For any matrix, if you want to get the number of rows and columns in that matrix, you can use the dim function or the dim function. It's a built-in function to find the amount of rows and columns in a matrix easily. After placing this comment here, just use the dim function by calling it only and insert the matrix name called new matrix. As you can see, the number of rows is equal to 2 and the number of columns or the amount of columns in this new matrix is equal to 2 also. Call that function only, and in between the round braces of that function place the existing matrix or the variable name that contains this matrix in between the round braces of the dim function, and you can select the statement and hit Ctrl Enter or use the run button to show the output on the screen. Also, you can use the length built-in function to find the length of a matrix or the dimension of a matrix. After this comment here, use the length built-in function and place the matrix name, and after running this statement you will get the dimension or the length of this matrix. The length of the new matrix is equal to 4, as you can see. The length of a matrix or the total cells in that matrix is the number of rows multiplied by the number of columns. In this new matrix here we have 2 rows and also we have 2 columns, so 2 multiplied by 2 is equal to 4. This is the length of the new matrix. Thank you so much for watching. See you again next lesson. Hello and welcome to this lesson about arrays in the R programming language. An array is a data structure in the R programming language that can hold multidimensional data. Arrays in the R programming language are objects that can hold 2 or more than 2-dimensional data compared to matrices. To create an array in the R programming language, use the array built-in function. The array built-in function is simply used to create an array, and also to specify the dimensions of that array, use the dim parameter or argument in between the round braces of the array function, and I'll show you all of that in action. Let's create our first array with 1 dimension with values ranging from 1 to 35, and after that, to show this array you can use the variable name 1dim or 1dim, and you will get this output here in the console. This array of 1 dimension ranging from 1 to 35, as you can see easily. Create a variable to this array, a special variable with a special name, and use the assignment operator to assign an array by using the C built-in function, and insert the range. The first range or the first number is included, and also the last number 35 is included here in this array. You can change this range to any range you wish. And after creating that array and assigning it to a variable, you can use that variable name to show the output on the screen to print out the result or this array in the console. And you can select all the code and hit Ctrl Enter, or use the run button from the top menu or the top side, and you will see this output in the console here. This range. This is a single dimension or one-dimensional array, as you can see. Let's use the dim parameter or the dim argument in between the round braces of the array built-in function. Let's create an array with the array built-in function, and in between the round braces of that function we are gonna use two parameters. The array name, this array name one dim, the first parameter or the first argument, and the second parameter will be the dimension parameter or the dim parameter. Let's see that to clarify everything and to make it understandable. Create a new variable called multi-dim, or any variable you wish, any name you wish, multi-dim, and after that assign the array built-in function to that variable. And the first parameter is the previous array 1dim, and the second one is the dimension for that array. We want to make the previous array multi-dimensional array with 5 rows, 4 columns, and 3 arrays. 3 multi-dimensional array. And you can see this output in the console here. 3 arrays with 4 columns and 5 rows. The first number in the C built-in function for the dim parameter is the number of rows. The second parameter is the number of columns, and the last parameter is the number of arrays. As you can see, the last number in the brackets specifies how many dimensions we want for that array. We have 3 dimensions in this case, simply 3-dimensional array. And to show this output in the console, use the variable name. The new variable name refers to the array built-in function in that case, which is multi-dim, the new variable, and select all the code, and you can hit Ctrl Enter to show this output in the console. You can create any array, you can create any multi-dimensional array by using the same method here. Use the dim parameter in between the round braces of the array built-in function to create multi-dimensional array with different dimensions. Instead of using these dimensions we set here. Do you want to access items from this array? If you want to access the array items, you can do that by using the index position for rows, columns, and also for the matrix level. Let's see that in action. You can use the square brackets after the name of the variable and set the row position, then the column position, and the last one the matrix level. The row position in this example is 3, the column position is 3 also, and the array level or the matrix level from this array, from this multi-dimensional array, is 2. So we want to access the item from the multi-dim array, and the position of this item is row 3, column 3, and this item inside the second matrix in this multi-dim array. And you can see the output for this program is equal to 33. This is the targeted item in this example here. This item in row 3, column 3, and also this item is placed inside the second array. And you can use the same syntax to access any item or any element from any multi-dimensional array. Use the row position, then the column position, and after that the matrix number or the matrix index number, as in this example here. Also, in the R programming language, you can access the whole row or column from the matrix you created in an array by using the C built-in function easily. We have an example here, and this example to access all the items from the first row from matrix 1, and you can see the result here in the console. We just got all the elements from the first row from the matrix 1 from the multi-dim array we created previously. And also you can do the same thing with columns. You can access all the elements from the first column from matrix 1 or any matrix from inside the multi-dim array or any array you created, any multidimensional array. Let's see that also. In the console, type the name of the array, of the multidimensional array, followed by square brackets, and inside these square brackets insert comma, then C, and in between the C built-in function put 1, then comma, then 1 outside of the C built-in function, and you will get all the items from the first column from the multi-dim array from matrix 1, from the first matrix in this multidimensional array. After the multidimensional array name and inside square brackets, if you insert a comma before the C built-in function, that means we want to access the column, and inside also square brackets after the multidimensional array name, a comma after the C built-in function, that means we want to access the row. You can use the in operator in the R programming language in between two percentage sign to find out if a specified item is present in an array or not. And we have a simple example here to check if 3 is present inside the multidimensional array, is present in this array or not. And you know 3 is inside this array, so the program will give you true in the output. The output is a logical value. The output for this operation will be true or false. If this number or this value is inside the array, the program will give you true, and if is not, the program will give you false. Let's try to use another number or another value that is not inside the multi-dim array in this example. 100 is not inside the multi-dim array in this example, so the program will give you false in this case, not true. And you can try any number instead of using these two numbers here. You can use the in operator in between two reminders or two percentage sign to check if an item or if a value is present in an array or not, simply using the same way. If you want to get the dimension or the amount of rows and columns in an array, you can use the dim function. The dim function is a built-in function in the R programming language, as in this example here. We use the dim function, and in between the round braces of that function you can see our array name, the multi-dim array here in between the round braces of the built-in function dim. And after running this statement, you can see the output, the number of rows, then the number of columns, then the number of arrays or matrices inside that array called multi-dim. The number of rows is equal to 5, the number of columns in this case in this array is equal to 4, and the number of matrices inside the multi-dim array is equal to 3. That's it easily. The dim function is a built-in function in the R programming language to find the number of rows, columns, and matrices in an array, exactly as we did in this example. Also, you can use the length built-in function to get the length or to find the length of an array easily. As in this example here, the length of the multi-dim array is equal to 60. Just use the length built-in function. You need to call it only by using its name, and in between the round braces of that function, place the multidimensional array name, as in this example here. The multidimensional array in our example is called multi-dim. Place it in between the round braces when we call the length built-in function, and select that code and you can hit Ctrl Enter or use the run button to show the output on the screen. Try by yourself to create multi-dimensional array and use all the previous methods we used here in this example. And if you need any help, please ask me and I'll answer you as soon as possible. Thank you so much for watching. See you again next lesson. The most common way in the R programming language of storing data is the data frame. The data frame simply is the data structure most often used for data analysis. And also, any data frame is a list of equal length vectors. Each element of the list can be thought of as a column, and the length of each element of the list is the number of rows. What is the meaning of that? The meaning of that a data frame is displayed in a format as a table. Also, any data frame in the R programming language can have different types of data inside it. While the first column can be character or string, the second and third can be numeric or logical or any data type. However, each column should have the same type of data. You have to put the same type of data in the same column. And if you want to create a data frame in the R programming language, it's so easy. Just use the data.frame built-in function. And inside the round braces of that function, you can place vectors and separate between them using commas. And I'll show you all of that in action to clarify that and to make everything understandable. Let's start by creating our first data frame called newDF. This is a special variable name, and use the data.frame built-in function, and in between the round braces of that function place any number of vectors you wish and assign them to variables. As you can see here, the first item called the players, and its value is a vector or a list of values: Ronaldo, Messi, then Salah. Then comma, then the second one or the second item is called numbers, and its value is another list of items or a set of items. This is a new vector by using the C built-in function 7, 30 and 11, as you can see. After that comma, after that height, this is the last one, the last item in this data frame easily. And if you use the variable name or the data frame name called newDF and select all the code, use the run button or use the control enter to run this program, you will get this data frame. You can see the headers of columns, players, numbers and height. And after that you can see the first row contains Ronaldo, the first item from the players item in the newDF data frame, then the first item from numbers 7, then the first item in the height item, and this number is 187. That's it. And you can take a look at the second row and the third row. And in this data frame in the console, you can see before each row the index number for that row, 1, 2 and 3 for the last row. For statistics and data analysis, there is an important function, an useful function. You can use it to get the statistical summary of this data frame, which is the summary built-in function. As you can see, place the name of this data frame as a parameter or as an argument for the summary built-in function. Then after running this statement, you can see statistical summary for the newDF data frame here. In the console, we got this useful information here. For players, the length is equal to 3, class is character, mode is character. Then for the numbers column, the minimum, maximum, median, mean and so on. Very useful information. And the same thing for the height column from this data frame called newDF. You can use the summary built-in function to get a statistical summary for data analysis and to get useful information about any data frame you created by using the data.frame built-in function easily as in this example. You can access any value you wish from any data frame you just created by using the index numbers. Just place the index numbers in between square brackets after the data frame name, and also you can use single brackets, single square brackets, double square brackets, or you can use the $sign to access columns from a data frame easily. Exactly as in this example here, we used newDF followed by 1 inside square brackets to access the first column from the data frame called newDF, and for the second column we use newDF, the name of the data frame, followed by square brackets and 2. 2 is the index number for the second column from the data frame called newDF easily. You can access the third column by using the index number 3. And also you can use square brackets, single square brackets, double square brackets instead of using single square brackets as in this example, or you can use the $sign before the column name to access it. And remember, the first column has the index 1, the index number for the second column is 2, and so on. If you want to access any column from a data frame, you can use square brackets instead of using single square brackets as in this example. Just place the column name inside double square brackets and you will get the output in the console once you hit Ctrl Enter. As shown here in the console, this is the column called players from the newDF data frame, and you can select any column by using its name in between double square brackets after the data frame name. You can access any column also by using $sign after the data frame name, then the column name, numbers for example, and hit Ctrl Enter. You will get all the column values. As you can see, the values of the numbers column from the newDF data frame are 7, 30, and 11 as in the console here. Try to access the height column by yourself by using double square brackets and also by using the $sign as in this example here. In order to add new rows in a data frame, you can use the append function. It's a built-in function in the R programming language. Just create a variable called addNewRow to df and assign the append function as a value to this new variable we just created, and the first argument will be the data frame name newDF we created previously, and after that the second argument or second parameter for the append function to add this new row to the newDF data frame. Just place new value Pogba for example. To add new row, you need to place a value for the first column Pogba, then a value for the second column 6, and another value for the third column, which is the height column, which is equal to, in this case, 191. To add this new row, just use the variable name, the new variable name addNewRow to df, and select all the code, and you will get this output. As you can see, a new row is added to this data frame we created previously called newDF. Pogba is added at the end of this table or this data frame we created here. Pogba for the first column, 6 for the second column called numbers, and the last one for the height column. That's it, easily. This is the fourth row or the last row we just added to this newDF data frame by using a new variable and by calling the append function to add a new row to the previous data frame we created called newDF. The first parameter for the append function is the data frame we created. We have called newDF, then a new vector to add a new row. The first value Pogba, the second value 6, the third one 191. and 91, as you can see easily. You can add more than one row by using the rbint function also. And if you want to add columns for any existing data frame, you can use the cbint function to add new columns in any data frame you created. The cbint function call it only, like this example here. The first parameter is a new df data frame, and the second parameter or the second argument is the new column with the new name called steps. You can name it any name you wish, and its vector, its sequence or set of values 100, 110, 120 in between the round braces of the C function. And once you use the variable name add column in data frame, after that and select all the code, then run the program, you will get this output in the console. You can see a new column is added at the end. It's called steps. The first item for the steps column is 100. The second item or the second value for the second row and also inside the steps column is equal to 110, and after that the last item 120. Also you can use the cbint function to add more than one column if you wish. If you have a data frame and you want to delete rows and columns from this data frame, you can do that. You can do this easily by using the C function to remove rows and columns in a data frame like this example here. This code here will remove the first row and column from the new df data frame easily. Select all the code and you can see the first row and column are removed from the new df data frame easily. Just you need to create a variable and assign the data frame name to that variable, and inside square brackets after the data frame name use -c minus then the C function and the index number for the row that we want to remove, and the second parameter you can see -c again. 1 is the index number of the column that we want to remove in this example here. That's it. Easily, as you can see, you can insert any index numbers if you wish, and you can see the output in the console after running the whole code by selecting it and hitting Ctrl Enter or using the run button. To get the dimension of any data frame you can use the dim function. It's a built-in function in the R programming language. The dim function is used to find the amount of rows and columns in a data frame easily. Just use it, and in between the round braces place new df, our data frame name we created, and you can see the number of rows is equal to 3 and also the number of columns is equal to 3. And if you want to get the number of columns only, you can use the incol function or the number of column function to find the number of columns, and to find the number of rows only you can use the nrow function. These are built-in functions in our programming language to find the number of columns and also the number of rows. Let's see that also. After the length of data frames comment, use the incol function, and in between the round braces place the data frame name new df, run the statement, and you will get the number of columns 3. As you can see, 3 columns in the new df data frame, and also you can use the nrow function to get the number of rows. Let's see that also. Go ahead and call the nrow function by using its name followed by round braces and place new df as a parameter for the nrow, and you can see the output in the console after running this statement. The number of rows in the new df data frame we have is equal to 3 in this case. You can use the nrow function for any data frame to get the number of rows easily. If you want to find the full length of any data frame, you can use the length built-in function. The length built-in function will give you the length of any data frame. The length of any data frame is the number of columns in the data frame, as in this example here, the length built-in function, and in between the round braces of that function you can see the new df data frame, the name of the data frame. This is the argument for the length function. You don't need to design that function from the ground up. Just call it and hit Ctrl Enter on the same line, or select the code and hit the run button or the Ctrl Enter, and you will see the output in the console exactly as you can see. We got 3, the number of columns. This is the length or the number of items in the new df data frame. In R, you can use the rbend function also to combine 2 or more data frames vertically by using the rbend function as we said beforehand. Let's copy this data frame twice with 2 new names after this comment here, new df1, and copy it again after that, and we are gonna call it new df2, and then we are gonna combine these 2 data frames vertically by using the rbend function, the rbend built-in function in the R programming language. Just you need to create a new variable. You can call it any valid name you wish, for example new concat, and call the rbend function. This is the value of the new concat variable, and it has 2 parameters or 2 arguments. The rbend function has 2 parameters as you can see in this example, and once you run this program you will get this output in the console. The 2 data frames, new df1 and new df2, are concatenated vertically by using the rbend function. Due to using the rbend function with the 2 parameters or the 2 arguments, new df1, the first data frame, then comma, then the second data frame new df2, and after that the variable name new concat or any valid variable name you created. Then select all the code like this example here and hit Ctrl Enter, and you will get this output in the console. You will see the 2 data frames or as many data frames as you wish. All the data frames are concatenated in the output by using the rbend function. The new df1 and the new df2 data frames are concatenated vertically by using this way, and also you can do the same thing to concatenate data frames horizontally instead of vertically by using the cbend function instead of using the rbend function. Let's do that also. Go ahead and replace rbend with the cbend function, and you need to run this program again. Select all the code and run the program again, and you will get this output. You can see the 2 data frames, new df1 and new df2, are concatenated or combined horizontally by using the cbend function in this example, and you can see the output in the console here. Try to do this also by yourself, and if you need any help, please ask me and I'll answer you as soon as possible. Thank you so much for watching. See you again next lesson. Hello and welcome to this lesson about factors in the R programming language. Factors are simply used to work with categorical variables, variables that have a fixed and known set of possible values. Also, they are useful when you want to display character vectors in an alphabetical order. You can use the built-in function factor in the R programming language to create a factor, and in between this factor, place the C built-in function to create a vector, and that vector will be placed as an argument in between the round braces of the factor built-in function. And I'll show you how to use factors in the R programming language step by step to categorize data simply by using the factor built-in function, and in between the round braces of the factor built-in function in R, the C function to create a vector as an argument inside the factor and to create that factor. Let's see all of that in action to make everything clear to understand. Let's take an example to create a factor of 8 items. This factor is called new fruits. As you can see, the factor built-in function, we assign it to this variable, and you can see the C built-in function to create this vector as an argument in between the round braces of the factor built-in function, and you can see the sequence of values for that vector here: banana, fig, lemon, lemon, cherry, banana, fig, and the last one, banana. As you can see, a vector inside the factor built-in function. This is the easiest way to create a factor in the R programming language, by using the factor built-in function and place a vector in between the round braces of that function easily. And after using the factor name or the variable name, just select all the code and hit Ctrl Enter, and you will see this output in the console here. You can see the output is our factor we created here. Simply to print out this factor, use the variable name or the factor name after creating it, like new fruits in this case. The output in the console is banana, fig, lemon, lemon, cherry, banana, fig, and the last one, banana. As you can see, this is so easy and so simple. You can see the levels also: banana, cherry, fig, and lemon. This new fruits factor has 4 levels or categories. You can see banana, cherry, fig, and lemon. And you can use the levels built-in function in our programming language to only print the levels of any factor easily. Let's do that. After the factor levels comment, let's call the levels function and place the factor name new fruits as a parameter or as an argument for the levels built-in function. Then run the program or run this statement by using Ctrl Enter, and you will get this output in the console: banana, cherry, fig, lemon. The levels of this factor only using the levels built-in function. You need to call it only if you want to print out only the levels of the new fruits or any factor. You can use the levels built-in function with any factor. Place it as an argument in between the round braces of that function, and hit Ctrl Enter or select all the code and hit the run button, and you will see the output in the console like this example easily. Also, it's possible to use the levels built-in function inside the factor built-in function, inside the round braces, to set the levels you wish. Let's create a factor, and this factor, as you can see here, our previous factor, and after that hit comma, and after placing this comma, set the levels you wish using this vector, the C built-in function, to create the levels you wish: lemon, banana, and after that set any levels you wish: cherry, and other after that. If you try to run this program by selecting it after using the variable name, you will get not available for fig, as you can see, because fig is not available in these levels we set here. You have to put fig in between the round braces of the C built-in function here for this vector for levels. So try to change other, for example, to fig, and you will see the output correctly. You will see banana, then fig, lemon, lemon, cherry, banana, then fig again, and banana, instead of seeing this not available in between tags in the output. And after that you can see the levels: lemon, banana, cherry, other. In this case, we are gonna replace this other with fig easily. Just go ahead and replace other with fig, and after that select all the code and hit Ctrl Enter to see the difference in the output. As you can see, instead of seeing other after cherry in levels, you can see in this case fig instead of showing or seeing the other simply. And banana, then fig instead of not available, lemon, cherry, banana, then fig again instead of using not available like the previous example, and after that banana, the last item in this factor easily. By using the levels parameter in between the round braces of the factor built-in function, you can set levels, any levels you wish, using a vector as a value for the levels parameter inside the factor. In order to get the number of items available in a factor, use the length built-in function in R. Just call that function and place the factor name as a parameter or as an argument for this function, as in this example here, length, and in between the round braces we placed new fruits as a value or as a parameter for this length function. And once you run this program or run this statement by hitting Ctrl Enter, you will get this output, the number of items in this factor, in this new fruits factor. The number of items available in the new fruits factor is equal to 8, as you can see. This is the length of the new fruits factor. You can do that, you can use the length built-in function with any factor. Just place it in between the round braces as an argument for the length built-in function. You need to call it only by using its name. It's a built-in function. You don't need to design that function from the ground up or something like that. If you want to access items from a factor, you can use the index numbers. And the index number for the first item in a factor is 1, and the index number for the second item is equal to 2, and so on. In this example here, to access the second item, use 2 inside square brackets after the factor name new fruits, and to access the third item, use 3 inside square brackets after the variable name or the factor name new fruits, as you can see. Once you run these two statements, you can see the output in the console. We got fig, the second item in the new fruits factor, and also for new fruits 3 inside square brackets we got lemon, the third item in this factor. Try by using the same way to access the fourth item that has the index 4 and the fifth item that has the index 5. Just use the factor name followed by square brackets and refer to the index number inside these square brackets as we did here. And also by using the index number, you can change any value from a factor after creating it. For example, let's change a value from this factor we created called new fruits, for example the third value, to cherry instead of lemon. And after that use new fruits with the index number. The new value will be printed in the output after using the index number. In this example here, hit Ctrl Enter to run this program and you will get this output cherry in the console easily, as you can see here. The new value instead of lemon. The third value in the new fruits factor is changed from lemon to cherry. You can change any value by using the same way. Use the factor name followed by square brackets, and in between these square brackets put the index number that belongs to that item and assign a new value using the assignment operator in the R programming language to this variable name or this factor name with its index number. And after that, try to use the variable name or the factor name with the new index number or with that index number to show the output on the screen exactly as in this example. Try to change the fourth item, the value of the fourth item from the new fruits factor easily, and if you need any help, please ask me and I'll answer you as soon as possible. Also, you should know that you cannot change the value of a specified item in a factor if it is not already specified in that factor. For example, if you want to change the third item to watermelon, you will get an error in this case because watermelon is not available in the new fruits factor. As you can see, invalid factor level not available generated, as you can see easily. Watermelon, that value is not available in the new fruits factor. You cannot change the value of the third item in this example to a new value that doesn't exist or not predefined in the new fruits. Watermelon is not available here. Try to change it, for example, to fig, to cherry, to banana, or anything available in the new fruits factor. And if you try to change it again to cherry, it will work in this case. However, if you have already specified it inside the levels argument in between the factor built-in function, it will work. In factors, if you try to change the value of any item and that value is available in the levels parameter in the vector for the levels parameter in the factor built-in function, in this case the program will work without any problems and you can see the output in that case. In these levels, in this example we have here, try to set apple in the levels parameter in the vector of the levels parameter, and after that try to change the value of the third item to apple instead of cherry and see the difference in the output in the console. Thank you so much for watching. See you again next lesson. Conditional statements in the R programming language. Hi everyone, welcome to this lesson. Conditional statements in R are used to make decisions based on the conditions. In other words, you can say that conditional statements are used to decide the flow of execution based on different conditions. If a condition is true, the program will perform or will execute the code. And if the condition of the conditional statement, the program will not execute this code and will skip the block of code and will continue with the next one. And to define the scope in the code in the R programming language, we use curly brackets. Curly brackets to define the code or to define a block of code in our programming language, and I'll show you how to use these blocks by using conditional statements, using the if keyword to define the conditional if statement, the else if keyword, and the last one, the else statement or the else keyword. If the condition of the conditional if statement is true, the program will execute the block of the conditional if statement, will execute all the code from inside the conditional if statement block. And if the condition of the conditional if statement is false, the program will skip this code and will continue with the else if conditional statement, and the program will test the condition of the else if conditional statement also. If the condition of the else if statement is true, the program will execute its body, will execute all the code from inside the body of this else if statement. And if all the previous conditions are false, then the program will execute the else statement block directly in this case if all the previous conditions are false, and I will show you all of that practically. To start the conditional if statement, we need to create two variables, in this example x and its value is 25 and y its value is 100. The conditional if statement by using the if keyword and its condition, in this case y is greater than x. If this condition is true, the program will execute the body of the conditional if statement, and the program will execute the print statement to print out the value of y is greater than the value of x message, due to using the print function to print out this message or this string data type on the screen through the console. And if the condition of the conditional statement in this example is false, the program will skip the conditional if statement and you will not see anything in the output. But in this case, the condition of the conditional if statement is true. The value of y actually is greater than or larger than the value of x. 100 is greater than 25. So in this case, the program will execute the body of the conditional if statement. And you can see the body of the conditional statement is inside curly brackets. The R programming language uses curly braces to define blocks of code and to recognize any block of code for the conditional if statements. Use curly brackets and insert all the statements inside these curly brackets related to the conditional if statement. Now we need to run this program to show the output on the screen through the console. Select all the code and hit Ctrl Enter or use the run button to show the output. You will get the value of y is greater than the value of x on the screen. Select all the code and hit Ctrl Enter or use the run button, and you can see the output in this case is this message from the body of the conditional if statement. Based on the condition of the conditional statement, the value of y is greater than the value of x. This is a true condition, so the conditional if statement executed. Based on this true condition, y is greater than x, 100 is greater than 25. And if you try to change this condition to false condition, you will not see anything in the output. Let's change it. Go inside the round braces of the conditional if statement condition and change greater than to less than or smaller than. And in this case, select all the code again and hit Ctrl Enter, and you can see nothing in the output in this case because this condition now is false. 25 is not greater than 100. 100 is greater than 25. So this condition is false. After this conditional if statement block, you can add another condition by using the else if statement. To add another condition, if the previous condition is false, like this example here, this condition is false. So you can add the else if statement to insert another code with another condition, and if the new condition is true, the program will execute the body or will execute the full code from inside the body of the else if statement based on the new condition. And you can see the new condition for the else if statement is true, y is greater than x. So the program will skip the first condition for the conditional if statement and will continue to execute the second condition for the else if statement, and the program will print out the new result on the screen through the console easily. You will see the new message, the value of y is greater than the value of x. In this case, the program will not execute the value of y is smaller than the value of x message because the conditional if statement condition is false. So the program will leave out or will skip this condition or will skip the body of the conditional if statement and will read and execute the condition of the else if statement because the new condition is true. In this case, y is greater than x. So the program will execute the print function from the body of the else if statement to show the new message, the value of y is greater than the value of x. You need to select the new code, the full program, and hit Ctrl Enter or use the run button to show the output in the console in this case. Go ahead and select all the program, then hit Ctrl Enter, and you can see the value of y is greater than the value of x message in the console related to the else if statement based on the condition of the else if statement, and the program skips the condition of the conditional if statement. Now it's time to talk about the else statement, but first let's change the value of x from 25 to 100 to make the condition of the conditional if statement false, and also to make the second condition of the else if statement also false. In this case we have two false conditions, so the program will not give you anything in the output if you try to run it or execute this program. You will see nothing in the console because the conditional if statement condition is false. Y is not smaller than x, y is equal to x in this case, 100 for x and 100 also for y. And for the second condition, this second condition also is false. Y is not greater than x, y is equal to x, so the second condition also the program will not execute the first one and the second one. You need to insert the else statement to execute the body of the else statement or the else block if all the previous conditions are false. So let's do that. Let's use the else statement here. After the closing curly brackets of the else if statement, type the else statement, and inside the body of the else statement use the print function to print out x equals to y, to print out this message if all the previous conditions are false. And there is no condition for the else statement, just type the else keyword followed by curly braces and insert the statements related to this keyword or this block inside the curly braces of the else statement, like the print function to print out x equals to y on the screen. And the program in this case will execute the body of the else statement, will execute the else statement because all the previous conditions in this case are false. The program will skip the conditional if statement, then it will skip the conditional else if statement because its condition is false also, and the program will go to execute the else statement because all the previous conditions are false in this case. And once you run this program you will get x equals to y, the message from the else statement on the screen through the console. We are gonna select all the code, then hit Ctrl Enter, and you will get this output on the screen. As you can see, x equals to y from the else statement block easily. This is an easy process. Try to do this by yourself also. Try to create two variables with different values and set conditional if statement to print out any message, then else if statement, and after that the else statement, and see the differences and how it works. I hope that you enjoyed this lesson. If you need any help, please ask me and I'll answer you as soon as possible. Thank you so much for watching. See you again next lesson. Hello everyone, welcome to this lesson. When programmers and developers write code, loops allow them to shorten what could be hundreds of lines of code to just a few. Basically, loop allow you to write the code once and repeat it as many times as needed, as many times as you wish. You can simply execute block of code as long as a specified condition is reached. And also you can iterate over sequences by using loops, and this will save your time. This is so important because this will save your precious time, reduce errors, and they make code more readable, understandable, and will make the program more organized. There are two types of loops in the R programming language. The first type or the first command is called the while loop, and the second type is called the for loop. In this lesson you will learn how to use the while loop easily in the R programming language. To define the while loop, Just start the line or start the code by using the while keyword. The while keyword is a reserved keyword in the R programming language, and you can use this command to start the while loop easily. To write the block of code once and repeat it as many as you wish based on the condition of the while loop, based on the condition that will be placed into the round braces of the while keyword after the while keyword directly. Let's see all of that in action. You can use the while loop in the R programming language to execute a set or a series of statements as long as a condition is true. In this example here we have a while loop. First of all, we declare the variable called x to use this value inside our while loop. You have to create a variable first to start the while loop and to use the value of this variable in the condition and also inside the body of the while loop. The value of that variable using the assignment operator is equal to 1. And you can see we start the while loop by using the while keyword, followed by round braces, and in between the round braces, this is called the condition of the while loop. This condition or this test expression is x is smaller than or is less than 10. The while keyword in this example will execute this set of statements inside the body of the while loop, from the body of the while loop in this example, as long as this condition of the while loop is true. So in this example, you will get the numbers from 1 to 9, but 10 is not included because 10 is not less than 10. This is not true here. 1 is true because 1 is smaller than 10. Also 2 is smaller than 10, 3 is smaller than 10, and the incrementation or the increment process in our case here from 1 to 9, due to using this increment operator, x plus 1 is the value of x. This statement for incrementing x by 1 from 1 to 2 to 3 to 4 and so on. So the program in this case will display numbers from 1 to 9 because 9 is the last one here, is the last valid number for this condition, is the last true number in this condition. And after that the program will break automatically. Let's see the out by running this program by selecting all the code and hit Ctrl Enter or use the run button to show the output of that program. You will get numbers from 1 to 9. Go ahead and select the code, our program here, hit Ctrl Enter, and you will get this output in the console as you can see. 1, 2, 3, 4, 5, 6, 7, 8, and the last one 9. The last true number based on the condition of the while loop in this case is 9 because 9 is smaller than or is less than 10. But if you try to put smaller than or equal to, you will see 10 will be included in this case. In the condition of the while loop, let's place smaller than, less than, or equal to. In this case, put the equal sign here, and after that run the program again, and you will see 10 is included now because 10 is true in this case based on this condition. 10 is equal to 10 in this case, and you can change this condition to any condition and see the differences in the output to show and to see how it works. Now you can use the break statement to stop this loop based on a condition. You can use the break statement in the R programming language inside loops, inside the while loop like that, to stop the loop even if the while loop condition is true. Type use break to stop. This is a command to stop the loop, and after that use the conditional if statement to set a condition. If x, for example, is equal to 5, and inside the body of the conditional if statement use the break statement. The break statement in this example will stop the loop even if the while condition is true. In this case, if the condition of the conditional statement in this case is true, the program will stop the loop automatically, will break the loop. So the last number in this loop will be 4. Let's run this program by hitting Ctrl Enter, selecting the code, and hit Ctrl Enter or use the run button to show the output. Go ahead and select all the code, then hit Ctrl Enter, and you will get the output in the console. As you can see, numbers from 1, and the last number is 4 in this case, not 5. Why? Because if you put 5 in the condition of the while loop, you will see 5 is true. And after this true condition, the program will go inside the body of the while loop, and the program will read the print statement or the print function to print X. So after that, you can see the increment operator, and the program will read and execute this increment operator. So in this case, X will be 6, not 5, due to using X plus 1 here. So the new value of X before using the conditional if statement to break or stop the loop, the value of X before this conditional if statement is equal to 6. This is for 5. 5 in the condition and 5 inside the body will be 6 due to using this increment operator. And after that, if X is equal to 5, this condition now is false because the new value due to using the increment operator for X is equal to 6. 6 is not equal to 5, so the program will not execute this condition or will not execute 5. So the last one or the last number in the output in the sequence inside the console is equal to 4, not 5. That's it for this lesson. Thank you so much for watching. See you again next lesson. Hello and welcome to the second type of loops, which is the for loop. You can use the for loop to write the code once also and repeat it as many times as needed. And you can use the for loop to iterate over a sequence like vectors, arrays, lists, or any sequence. You can easily execute a set of statements by using the for loop once of each item or each element in a vector, array, list, or any sequence. And this will save your time, reduce errors, and this will make your code more readable and organized also. You can define the for loop in the R programming language by using the for keyword. And in between the round braces after the for keyword, you can place valid variable name that represents each item in the sequence. After that, the in keyword followed by the sequence name or the sequence itself. And inside the curly braces of the for loop, you can place the code related to this for loop easily, and I will show you that practically. At the beginning, use the for keyword followed by round braces and place I in this sequence from 1 to 15. I is a variable here we created, and after that, inside the curly braces of the for loop, you can see the print statement or the print function to print out the value of I. The value of I will be from 1 to 15, one by one, based on this sequence. I will represent each item in this sequence. I will represent 1, then after displaying 1 after the first loop, I will represent the second item, which is equal to 2. Then after displaying 2 in the sequence, I will represent 3 and so on. And the print statement will print out the output in the console for each number. So you will get sequence of numbers or a loop of numbers from 1 to 15. 1 is included and also 15, the last number, is included in this case here. That's it. The variable name followed by the in keyword followed by the sequence, or you can assign this sequence to a variable and you can insert the variable name in this position of the sequence inside the round braces of the for loop after the in keyword directly. Now we need to select that code or this program and running it by using the run button or executing it to see this output or this sequence of numbers in the console. Let's go ahead and select the for loop, the whole code from here, and hit Ctrl Enter to show this sequence in the console. You can see this output, numbers from 1 to 15, 1, 2, 3, 4, 5, all the sequence from 1 to 15, 1 is included in the output, and also the last number 15 in this range is included in the output. This operation, as you can see, is so easy and so simple. You can try this with different range. Instead of using from 1 to 15, you can use from 10, for example, to 100 or any number and see the differences in the output. As we said previously, you can use the for loop to iterate over sequences like vectors, like lists, and in this example I'll show you how to iterate over a list, how to use the for loop to iterate over this list. Here we have a list of 4 items: banana, apple, fig, and lemon, and this list is called fruits. And after that you can see the for loop by using the for keyword. The for loop after this list easily is used to iterate over the list items one by one. I, in this case, in between the round braces of the for loop, will represent each item, will represent banana, and after printing banana by using the print function, I will represent the second item, apple, then the next one, fig, and the last one after that, lemon. So you will get all the items one by one from the first one to the last one. You will get banana, apple, fig, lemon one by one due to using the for loop in this case. And in between the round braces of the for loop, you can place any variable name instead of I. You can place, for example, item. You can replace I with item, with variable, or any valid variable name in the R programming language, followed by the in keyword, followed by the list name. In this case, the special name for that list is fruits. The for keyword will execute the set of statements based on the condition or the test expression of the for loop. In this case, the test expression is I in fruits, I in the sequence of items or the sequence of multiple items in the R programming language. Now we need to run this program to show the output in the console. You will get the items of this list, of the fruits list, one by one. Just go ahead and select all the code and hit Ctrl Enter, and you will get this output in the console here. Banana, then apple, then fig, then lemon. I represents each item one by one, in this case in the for loop. So the program will display each item one by one, and the print function prints banana, then apple, then fig, then lemon. This is our loop. You can use the for loop to iterate over any sequence using the same way. Assign a sequence to a variable, then after that you can use the for keyword to start the for loop and place a variable name, valid variable name, to represent each item in that sequence, followed by the in keyword, followed by the sequence name, and inside the curly braces just use the print function followed by braces, round braces, and place the variable name, the valid variable name that you created in between the round braces of that print function easily, and you will get the output once you execute the program by using Ctrl Enter or using the run button from the top side. Try with another list and see the differences in the console. Let's take another example to make everything clear to understand. Let's iterate over a vector. A vector also is a sequence of values, and this is called, in this case, numbers. This vector is called numbers, and we have this vector of 4 items here from 10 to 40, and the for loop after that to iterate over the sequence of values or the sequence of numbers. In this case, the for keyword followed by the variable name num, in this case, that will represent each item one by one. For each loop, followed by the in keyword followed by numbers, the variable name or the sequence name. This is our vector name in this example. And after that, inside the curly braces of the for loop, the print function to print out the variable name or each item one by one. Num will represent 10, then will represent 20, and so on until reaching the last item of that loop. And you can see the output in the console. Once you run this program, select all the code and run the program by hitting Ctrl Enter, as you know beforehand, and you will get the values from 10 to 40, all the values of this vector one by one. You can try with another vector with any other values instead of using these values. Using the for loop in the R programming language is so easy. Just assign or declare a sequence, and after that you can use the for keyword or the for loop to iterate over this sequence by using this way easily. If you want to stop this for loop in a specified item in the sequence, you can use the break statement to do that. With the break statement, you can stop the for loop before it has looped through all the items of the sequence, exactly as we did previously with the while loop. Just set a condition, and this condition by using the conditional if statement, as in this example here, if num is equal to 30, the third item in the vector called numbers, then break if num is equal to 30. So once you run this program, you will get the first item, then the second item. The third item is not included in this example here, because the program in this case will break before printing 30, before using the print statement to print 30. So you will get the first two values in this numbers vector, 10 then 20. And you can do this by yourself also for any vector. You can do this for a list or any sequence of values. Also, there is another useful statement called next. You can use the next statement to skip an iteration without terminating the loop. Let's see that. To use the next statement, just replace the break statement with the next statement in this case, and you will see the program will skip 30 and will continue with the next value without terminating the for loop. You can see the program will display this output in the console 10, 20, and will skip this value based on the condition of the conditional if statement, and will continue with the next value 40. This is so easy and very useful statement to skip an iteration without terminating the loop, and you can use it with while loops and also for loops easily. Thank you so much for watching. See you again next lesson. To having repeating blocks of code in your program many times, you can use functions. A function is a series of related statements or a block of code which only runs when it is called. Once a function is defined or declared using the function built-in function in the R programming language, it can be used over and over and over again. Functions are used to increase the reusability of code, also to make the code more organized and readable. And to pass information or data into a function, use parameters. You can pass data or information into the function body easily by using parameters, and I'll show you that. In the R programming language, to define a function, you can use the function built-in function and assign this built-in function to a variable, and the variable name will be the function name easily. Let's take our first example to define a function in the R programming language. We have our example here. You can see we assign the function keyword or the function built-in function to a variable using the assignment operator, and the variable name in this case or the function name is called greeting. Just you need to place the function keyword with empty braces, as you can see, as a value for the greeting variable, or you can give this variable any name you wish. Try to make the function name more descriptive and also meaningful. And you can see the body of that function in between curly braces. After the function keyword and also the round braces, you can see curly braces, and in between these curly braces you can see a statement, the print function. The print function to print out this message or this string data type on the screen, sequence of characters. And that sequence of characters is the hello everyone message. And once you call that function, you will see the output on the screen for this statement, the function body. In this example here, if you try to run this program without calling the function greeting, you will not get anything in the output. The program will show you nothing in the console. And to call a function, just use the function name. In this case, the function name is called greeting, followed by round braces or parentheses. After that comment, calling function, just call the greeting function by using its name followed by round braces, empty round braces in this case because there are no parameters for that function. So empty round braces after the function name, and run this program. Select all the code, and after that you can use the run button or you can use Control Enter to show the output for that program. And you can see in this case the output in the console, the hello everyone message. The program will execute the body of that function once you call that function called greeting easily. And also you can call the function as many as you wish. You can use the code many times because functions increase their usability. So you can use the same block of code many times by calling this function as many as you wish. For example, here we call this function called greeting 3 times. And once you run the program, you will get the output on the screen. You will get the hello everyone message 3 times. You can pass information or data into the function body by using parameters. And we have an example here, a function called fullName. We declared that function by using the function keyword and assign this function to the variable name or the function name called fullName. And in between the round braces of the function keyword, in the function header you can see the parameter called ifName or first name, or you can name this parameter as many as you wish. Try to put valid variable name, and you can call that function called fullName by using different values or different arguments for this parameter called ifName. For example, here we call that function only a single time. For a single time here, fullName followed by round braces, and in between the round braces the value of ifName, the ifName parameter in this case is equal to Ahmad. You can insert any different value, and this value will be passed into the function body, and the paste function in between the curly braces of that function will concatenate Ahmad with Ibrahim, the 2 strings or 2 characters in this case. So let's run this program to show the output on the screen. Once you run this program by hitting Ctrl Enter or using the run button, you will see this output in the console. The message or the full name Ahmad Ibrahim. The value in the function calling called Ahmad is passed into the function body by using the fname parameter. This is the value of the fname parameter. And the position, as you can see for this string data type, is before the Ibrahim string in between the round braces of the paste function. And the paste function is used to concatenate these two strings in this case. Also, you can add as many parameters as you wish in the function body. As in this example here, we just added job, another parameter in between the round braces in the function header. In between the round braces of the function keyword, you can see if name followed by comma, then job. You can place another comma and you can place another parameter if you wish to pass information into the function body. And also, after Ibrahim in between the round braces of the paste function, we placed a string data type called is, then comma, then the position or the placeholder for the job parameter or this information. The information or the data or the value of the job parameter will be placed in this position in between the round braces or in between the parentheses of the paste function. So in the function calling, we just added a data engineer as a new value for the job parameter. Ahmad is the value of the first parameter if name, and a data engineer is the value of the second parameter, the job parameter for this function called full name. Just place the name of the function followed by round braces. This is the calling of the function, and place a value for the first parameter or an argument for the first parameter and another one for the second parameter, simply as in this example. The meaning of argument is just the parameter value in the function calling. And in this example, if you try to run this code, this full code, you will get Ahmad Ibrahim is then the value of job in this case that will be passed into the function body, which is a data engineer. Let's run this program again to show the output. Select the full code or the full program and use the run button, or you can use Ctrl Enter and you will see this output in the console. The output as shown here in the console is Ahmad Ibrahim is a data engineer. Ahmad is the value of if name followed by Ibrahim, the string data type in between the round braces of the paste function, followed by the is string data type or character, followed by the value of the job parameter, in this case in the function calling, which is a data engineer easily. This is the full message or the full output based on this function body or based on this calling for that function. You can call it many times. You can call this function, for example, with different values for if name and also the job parameter. To return information or data from a function in the R programming language back to the caller, you can use the return function or the return statement. The return function in the R programming language is a built-in function that lets a function return data simply. Exactly as in this example here, we have a function called multiplication and it has a single parameter. And the value of this parameter will be passed into the function body, and you can use in between the curly braces of the function body, you can see the return function, and the expression of that return function in this case is 10 multiplied by n. So the value of n will be passed in the position after the asterisk symbol here in between the round braces of the return statement. And as you can see, the print function 3 times we call that function called multiplication 3 times with different values for the n parameter, 5, 15, and the last one is equal to 20. 20 is the value of n that will be passed into the function body. For the first calling, when the value of n is equal to 5, this value will be passed into the function body, so the returning value from this function back to the caller will be 10 multiplied by 5, will be 50 easily. And for the next calling, 15, the result in this case will be 10 multiplied by 15, which is equal to 150. And for the last calling, when the value of n is equal to 20, the result in this case will be 10 multiplied by 20, which is equal to, in this case, 200. The multiplication function in this example will return these three values. Let's run this program by selecting all the code and hit Ctrl Enter to show the output in the console. Once you run this program by using the run button or by using Ctrl Enter, you can see this output as shown here in the console. The first result is equal to 50. 10 multiplied by 5 is equal to 50. The second one, for the second calling, 150. This returned value back to the caller from multiplying 10 by 15. And for the last one, 10 multiplied by 20 is equal to 200, as you can see is. If you create a variable outside a function or outside the body of any function, this is called a global variable. You can use global variables in the R programming language both inside of functions and outside. We have a global variable in this example here called newStr, and the value of this variable is equal to fun. In this case, we store that value inside this variable called newStr, and once you call that function, the value of this variable will be used into the function body in the position of newStr in between the round braces of the paste function, and the paste function will concatenate the R programming language is string with the value, in this case, fun. So you will see this output on the screen inside the console. The newStr in this case works outside of the function called new function and also inside that function, so you can use it easily to pass information into the function body, exactly as in this example here. And for example, also if you try to create a variable with the same name inside that function called new function, this variable will be local and can only be used inside the function. If you try to create a variable called newStr in this example in the function body called new function, this will be local and can only be used in the function called new function. And also the global variable in this case with the same name, for example in this case newStr, will remain as it was, global with the original value, which is the fun string or sequence of characters in this example. So let's create a variable inside the body of that function called newStr to change the value from fun to powerful, and the new value will be work inside the function only. newStr is equal to powerful, as you can see. The new value in this example for the newStr variable will be work inside the function body only. Once you call that function, you will see the value of the newStr variable is powerful, not the fun string, exactly as in the output here in the console. The R programming language is powerful, and if you try to remove the newStr string or the newStr variable from inside the function body, you will see the global variable will work again inside the body of that function. But if you try to use the new str variable outside of that function, you will see the value of new str is fun, not powerful, because the value of new str powerful works only inside the new function, not globally. It works locally inside the function body called new function. So by using the print function outside the function body, as you can see, to print out the new str variable, you will get fun in this case, not powerful, because this is the global value for that variable called new str. And if you want to make the local variable new str from inside the new function works globally instead of locally, you can use the global assignment operator. The global assignment operator, exactly as you can see here, is used to create a global variable inside a function instead of outside the function. You can see the global value for the new str in this example by using the global assignment operator is powerful. So once you use the print function to print out new str outside the function body, you will get powerful. After using the global assignment operator, now you can select all the code and hit Ctrl Enter or use the run button from the top side, and you will get the output in the console. The output in this case, the R programming language is powerful, and by using the print function to print out new str globally, you will get this value powerful in this case, because this is the global value in this example by using the global assignment operator to assign powerful as new value for the new str variable inside the function body called new function. That's it. And also you can use the same global assignment operator if you want to change a global variable inside a function if you wish. If we have a global variable before the function called new function, and that variable called, for example, new str, you can change the value of that variable by using the global assignment operator inside that function. Thank you so much for watching. See you again next lesson. Hello and welcome to this lesson about statistics in the R programming language. You can use the R programming language for data analysis easily. The R programming language comes with several built-in data sets, for example, the mtcars dataset, and to list all the data sets available in the R programming language and all the features for this, you can use the data built-in function. Type the data inside the console, just the data built-in function with empty round braces to see the list of the preloaded data sets. And also you can calculate the minimum and the maximum value in a sequence or in a data set. And I will show you how to use the max and min functions to calculate the maximum and the minimum values inside a dataset easily. And also you can calculate mean, median, and mode. What is the meaning of mean? The meaning of mean is the average value in a sequence or in a dataset. Also, the meaning of median, the middle value. The median is the middle value in a sequence or in a list. And the last one, mode, is the most common value in a sequence. Also, you will understand the using of percentiles. Percentiles simply are used in statistics to give you a number that describes the value that a given percent of the values are lower than. And also in the R programming language, you can do more than that. You can calculate the variance and standard deviation and many more. In the R script, just type mtcars and hit Ctrl Enter or use the run button to show all the dataset called mtcars. You can see inside the console all the mtcars dataset. This is a so popular built-in dataset in the R programming language. And you can use this dataset easily for statistical purposes. By using the name of the dataset and hitting Ctrl Enter or using the Run button, you can see all the dataset inside the console, and we will work with this dataset easily to get the max and minimum values, and also mean, median, and mode, and also percentiles. Now, if you want to get information about this dataset easily, you can do that by using the question mark before the name of this dataset. Just use the question mark followed by the name of this dataset, and you can see inside the help side or inside the help section all the information about this dataset. You can take a look at this information by using this statement and running this statement to show the output inside the help menu or inside this help panel. All the information and details about this dataset or any dataset you use. The DIM function or the dim function is a built-in function in R to find the dimensions of the dataset, any dataset. Let's use the dim function with this dataset called empty cars to find the dimensions of this dataset. After placing this comment, let's use the DIM function, and inside the round braces insert empty cars, and you can see inside the console our result, in this case 32 rows and 11 columns. As you can see, these are the dimensions of this dataset called empty cars, and you can use any available dataset in the R programming language inside the round braces of the dim function using the same way, using this statement dim, and inside the round braces just put the name of the dataset and hit Ctrl Enter or use the Run button to run this statement to show the output in the console. And if you want to access all the variables available in the dataset called empty cars, you can use the names function. The names function is used to view the names of the variables from a dataset. You can use it with any dataset also. Let's use this function called names with this dataset called empty cars. Place a comment first before using the names built-in function. Type access variables from the dataset, and after that use the names function, and inside the round braces just use the dataset name empty cars in our case here, and you will get all the variable names available in this dataset. Hit Ctrl Enter and you can see inside the console all the variables. As you can see, you can use this statement simply to get the name of each column: MPG, CYL, DISP, and so on. Also, you can do the same thing with rows. You can use a function called row names function, and this function in the R programming language is used to get the name of each row in the first column, which is the name of each car in this dataset called empty cars. Let's use this function called row names function. Type a comment, row names, and after that comment use the row names function, and inside the round braces of that function place the dataset name empty cars and hit Ctrl Enter, and you will see the name of each row in the dataset called empty cars, which is the name of each car. A variable in a dataset is something that can be measured or counted, and if you want to print all the values that belong to a variable from a dataset like empty cars in this example, you can access the data frame by using the $sign. The $sign followed by the name of the variable, and you will get all the values. Let's see that. Let's use the empty cars with any variable from this empty cars using the $sign. Just type in this comment, print all the variable values from empty cars, and after that the name of the dataset empty cars followed by $sign, and after this $sign you can see MPG, the variable name, and you can see once you hit Control Enter or running this statement, you will see all the values of this variable from the dataset called empty cars. All the values are printed in the console easily. And if you want to sort all the values available in a variable, you can use the sort built-in function in our programming language. You can use the sort built-in function, and inside the round braces of that function, just place the dataset name, empty cars in our case here, followed by the $sign, followed by the name of the variable. Place this command first, sort variable values in empty cars, and after that, after this command, use the sort built-in function like this example, and inside the round braces, put the dataset name empty cars followed by the round braces followed by the variable name mpg in this case. Once you hit Control Enter to run this program or to run this statement, select it and hit the run button or Control Enter, and you will get the output exactly as shown in the console. This is the output. All the values are sorted one by one, as you can see. All the values of the mpg variable from the empty cars are sorted one by one, as you can see. 10.4, then 10.4, then 13.3, then 14.3, then 14.7, then 15.0, 15.2, and so on. To get a statistical summary of the data from a dataset, for analyzing the data, you can use the summary built-in function in the R programming language. You can use this function to get a detailed summary or a statistical summary of the data for any dataset you select. Just use the summary built-in function, and inside the round braces of that function, you can place the dataset name, or you can assign this dataset to a variable, and inside the round braces of the summary built-in function, use the variable name which stores the dataset. After placing a comment, get the summary, just use the summary built-in function, and inside the round braces of that function, use the dataset name, and you can see the statistical summary of this dataset called empty cars for minimum, median, mean, maximum number, and all the information. As you can see, this is a quick summary. This is very useful if we want to display a quick summary about any dataset, not only the empty cars dataset. In the R programming language, there are several built-in math functions like the min and max functions, and you can use these functions to find the lowest or highest value in a dataset. And in this example here, we assign the empty cars, the dataset we used previously, to a variable called new cars. You can use the max built-in function to get the highest number in a dataset or the highest value in the new cars. The new cars is the variable name which stores empty cars dataset in it. And also to get the minimum value or the lowest value for the empty cars in the empty cars dataset, use the function by calling it only. You don't need to design this function from the ground up. This is a built-in function, so call it only by using its name. And like the max function, use the new cars inside the round braces of the min function. And once hitting enter or running this program by using the run button, you will get the maximum value or the highest value in the empty cars. And you can see in this output, the maximum value is equal to 472, and the lowest number or the smallest number in the new cars or empty cars dataset is equal to 0 in this case. You can use the these two functions, max and min functions, with any dataset. Assign the dataset to a variable, and after that use the variable name as a parameter inside the round braces of that function to get the highest value with the max function and the lowest value or the smallest value using the min function easily. Do you want to get the largest and smallest value of the variable from a dataset? For that, you can use the which.max function to get the largest value in a variable, and also the which.min function to get the smallest value in a variable from a dataset. Like this example here. You can see in this case, the which.max function is a built-in function, and in between the round braces of that function, the variable name that stores the empty cars dataset, followed by $sign, and after that $sign you can see the variable name. The variable name from the dataset called empty cars is mpg. To get the maximum number or the maximum value from this variable, and also we use this variable again with the min function, the which.min function, and inside the round braces of that function also new cars followed by $sign followed by the variable name. And in this case you can see the maximum value or the largest value in the variable name called mpg is equal to 20, and the smallest value in the mpg variable is equal to 15 in this case. And from the empty cars you can use any variable name, not only the mpg variable. You can use any variable from this empty cars. Simply use the name of the variable which stores this dataset followed by $sign, and after that the variable name inside the round braces for the which.max function and also for the which.min function. For any dataset, if you want to get the average value for any variable, you can use the min function. The min function is available in the R programming language. Just use the name of the variable which stores the dataset followed by the $sign followed by the variable name inside the round braces of the min function, and you will get the output after running this statement. As you can see in this case, the output in our case, the output for or the mean or the average for this variable for all the values from the mpg variable is equal to 20.09 and so on. Try to get the mean of any variable from this dataset called empty cars using the same method. Use the min function and inside the round braces put the variable name followed by $sign and put any other variable name instead of mpg from the same dataset, and run the statement or the program and see the difference in the output. This is about how to get the average or the mean for a set of values or a variable from a dataset. And if you want to get the middle value in set of values in the R programming language, you can use the median function, and inside the round braces of that function place the variable name or the dataset name followed by $sign and the variable name, and you can see the midpoint in mpg inside the empty cars for this dataset is equal to 19.2, and you can use this statement or this function median for any variable from the dataset called empty cars, the current dataset, to get the median or the midpoint from a set of values or a variable in a dataset. The R programming language doesn't have a function to calculate or show the mode for a set of values or for any variable from a dataset, and you can use this statement to calculate the mode instead of using any function. You can use this statement, the names function, and inside the names function insert the sort function minus table, and inside the round braces of that function place the variable name or the dataset name followed by $sign and the variable name to calculate the mode for this variable or set of values. And after all of that, and outside the names function, use 1 inside square brackets. Simply you can use this statement or this code for any variable, for any set of values from any dataset, to get the most common value in a variable in a dataset, or the value that appears the most number of times. And in this example, the most common value in the variable called MPG, or the set of values from the empty cars dataset, is equal to 10.4, and this output is shown in the console by hitting Ctrl Enter or using the run button to run this program or this code. 10.4 is the most common value in the MPG variable from the empty cars dataset. Let's use the quantile function in the R programming language to specify which percentile you want. Percentiles are used in statistics simply to give you a number that describes the value that a given percent of the values are lower than. And in this example here, you can see the quantile function, and inside the round braces of the quantile function, you can see the first parameter is new cars, followed by $, followed by the variable name, and after that the C function, and inside the C function 0.75. And the output for this code, as you can see in the console, is 75% and followed by this number 22.8. What is the meaning of that? Okay, that means 75 of the cars have that MPG number or less. And to clarify that, you can use the quantile function without the C built-in function or the C parameter in this function or this round braces, and in this case you will get the percentiles of 0, 25, 50, 70 and 100%. Go ahead and remove this function and run the statement again, and you can see in the output 0% of the cars have this MPG or less, 10.4, and 25% of the cars have this MPG or less, 15.4, and so on until reaching the last item, which is 100%. 100% of the cars have this MPG or less, 33.9. That's it. That's all about quantile function in the R programming language. It's a built-in function, and inside the round braces of that function, just place the dataset name or the variable name that stores that dataset, followed by the $, followed by set of values or a variable available in the dataset called empty cars or any dataset you use. Thank you so much for watching. See you again next lesson. Hi everyone, welcome to this lesson about the plot built-in function to draw points or markers for data visualization. You can draw points and markers in a graph by using the plot function, and this function takes two parameters for specifying points in data visualization. The first parameter for the x-axis points and the second parameter for the y-axis points. The plot function is one of the most important functions for data visualization in the R programming language. You can use the plot built-in function with the two parameters for x point and y point, as in this example here, to draw only one point in a graph. The first point is 1, 5, 1 for x and 5 for y inside the round braces of the plot function. Now you need to run this function or hit Ctrl Enter on the same line, or you can select this statement and hit run using the run button, and you will see the output inside the plot section. And you can take a look at this data visualization to visualize this single point 1 and the y value is 5 in this case. You can see a single point. And you can hit the zoom button to show a larger version of this point or to clarify everything you can see here in the plot zoom tab. Also, by using the built-in function plot, you can draw 2 lines, 3 lines, or many lines as you wish. You can see in this example we have 2 points. We use the C built-in function in this example to combine the values of x with the values of y. The first point 1, 4. 1 for x and 4 for y. 1 from the first round braces of the C built-in function and 4 from the second round braces or the second C function. And the second point in this case is 9 and 11. 9 is the value of x and 11 is the value of y. And you can see these 2 points in the graph in the output inside the plots tab or the plots section. The first point is 1, 4. The second point 9 and 11. And this is in this case by using vectors. To draw multiple points or more points, use vectors like this example here. We just created a vector for the x values and another vector for the y values. Now let's use the same concept to draw multiple points using a vector for the x-axis and another vector for the y-axis. And you can see that inside the round braces of the plot built-in function. You can see the x values or the x vector 10, 20, 30 and 40. The y-axis or the y values 30, 70, 80 and 90. And once you select the plot function from here or this statement or this code and hit Ctrl Enter or use the run button, you will see the output inside the plots tab or the plots section. You can see we have 4 points. The first point 10, 30, the second point 20 and 70, the third point 30 and 80, the last point we have here 40 and 90. That's it simply. For best practicing, you should assign the values for the x-axis or the x-axis vector to a variable and also do the same thing for the y-axis. And you can use after that the 2 variables as parameters inside the round braces of the plot built-in function. Exactly as in this example here. You can see the x vector 10, 20, 30 and 40. And the y vector, we assign this vector for y to a variable called y, like we did with the x variable 30, 70, 80 and 90. And you can see inside the round braces of the plot function the 2 parameters x and y only. This is more clean, as you can see. This is for best practicing, and you will get the same previous result, the 4 points in the graph inside the plots section 10, 30, 20, 70, 30, 80 and the last one 40 and 90. This is the last point. Also, you can draw sequences of points. If you want to draw dots in a sequence in the graph on both the x-axis and the y-axis, you can use in this case the colon operator. Exactly as in this example here, we have created a variable called points, and you can see inside the plot built-in function this sequence from 1 to 15 for x and also for y. The same values for the x-axis and the same values for the y-axis. And to print out the result or to show the data visualization for the sequence, use the variable name after that and select the code, select this program and hit Ctrl Enter or hit the run button, and you will see this output inside the plot section. These dots, these sequences of points simply based on the sequence from 1 to 15 for x and y. And in between the 2 values you can see the operator colon. And if you want to use the plot built-in function without any variable, you can use it directly like that. The plot built-in function from 1 to 15 also, and you will get the same previous result in this case from 1 to 15 for X, and also from 1 to 15 for the Y-axis in this case. And by using the same sequence, you can draw line instead of using points. And this is by using the type parameter inside the round braces of the plot function. You can see the value of the type parameter in this case is equal to L to visualize data using line plotting instead of dots or points. Also for this sequence from 1 to 15 in this case, this is the first parameter for X and also for Y. You can add also headers and labels using the plot built-in function with parameters for the X-axis, Y-axis, and the whole data visualization for this example by using the main parameter in this case, and its value is data visualization, to add a header for our graph, and xlab to add a header or to add a label for the X-axis, and this label is the X-axis. You can change it if you wish. And to add a header or a label for the Y-axis, you can use the ylab parameter. The ylab parameter in this case is equal to the Y-axis. You can change it for anything else if you wish based on the graph. And you can see all these labels in the graph. You can see the main header is data visualization using the main parameter inside the plots side or the plots section, and the header or the label for the X-axis is the X-axis, this text, and for the Y-axis is the Y-axis text. You can change all of them if you wish. Also, there is a parameter to change the color of the plots or points or line, and this parameter is called cal parameter. You can set a value for this cal parameter, for example red, to draw red points, and also you can change it to green, to blue or yellow, or any color you wish. And if you try to remove this cal parameter, you will see the black color is the default value. Another useful parameter to change the size is called CEX parameter. The CEX parameter is used to change the size of the points, and the default value is 1, while 0.5 means 50% smaller and 2 means 100% larger. Just put that parameter inside the round braces of the plot built-in function after the sequence and run the program, and you will see the changes in the plot section in the graph. Let's add another useful parameter inside the round braces of the plot built-in function, and this parameter to change the point shape in this case, and this parameter is the PCH with a value from 0 to 25 to change the point shape format or style. Just set that parameter exactly as you can see, and try to change the value of that parameter from 0 to 25 and run the program for each change to see the differences inside the graph. I hope that you enjoyed this lesson. Thank you so much for watching. See you again next lesson. Hello and welcome to this lesson about line plots in the R programming language. A line plot or a line graph in the data visualization is used to connect all the points in the data visualization or in the graph. And to create a line plot in the R programming language, just use the plot function with a parameter called type and set a value for this type parameter called L. And this type is equal to L parameter is used to visualize the data of a specified sequence using the line plotting technique. Let's take an example and create a line plot by using that sequence from 10 to 20, and the parameter type is equal to L, and also let's change colors using the cal parameter. Our key function in this example here is the plot function, and inside the round braces of that function you can see the first parameter is the sequence from 10 to 20, and the type is equal to L to draw or to visualize data using the line plotting technique. And after that you can see the col parameter or the color parameter. The color parameter in this case is equal to red. And once you run this program or execute this program by hitting Ctrl Enter, select all the code and hit Ctrl Enter, or use the run button from the top side, and you can see inside the plots tab or the plots section our data visualization, in this case red line graph, as you can see, for this sequence from 10 to 20. Also you can change the color from red to blue or green or any color you wish. You can change it to yellow, and this color is black by default. Without using the col parameter you will see a black line. And if you want to change the width of this line, you can use the LWD parameter, line width parameter, and this parameter is used to change the width of the line. And the default width for the line is equal to 1, while 0.5 means 50% smaller and 2 means 100% larger. And in this case the value of this parameter LWD is equal to 1, and this is the default value also if you try to remove this parameter here from the round braces of the plot function. Let's change this value. You can change the width of this line from 1 to 2, as in this example here. You can see the line width is larger now. Also you can change the style of the line. The line is solid by default, and you can use the LTY parameter, as in this example, with a value from 0 to 6 to specify the line format or style. If you set the value of LTY 0, 0 will remove the line, 1 will display a solid line, 2 will display a dashed line, 3 will display a dotted line, 4 will display a dot dashed line, 5 will display a long dashed line, and the last one, the last value for the LTY parameter is 6. And if you set the value of LTY 6, 6 will display a 2 dashed line. This is so easy and so simple. You can draw many lines or multiple lines in the same graph. Let's take an example. Let's draw 2 lines. And to display more than one line in the same graph, use the plot built-in function together with the lines built-in function. In this example here, for the first line, the values for the first line or the first vector 2, 3, 4, 5, 6, and 7. For the second line, the values for the second line 3, 5, 7, 9, 11, and the last one is 13. And for the first line you can see we use the plot built-in function, and the first parameter is the line name or the vector that belongs to this line. First line, this is the variable name that contains that sequence of numbers from 2 to 7. The second parameter type is equal to L to draw a line or to visualize data using the line plotting, and the last one color for that line. The color of this line is equal to green. You can change it to red, to blue, to yellow, or any color, any valid color in the R programming language. You can use it easily. And lines for the second line, you can see here we use the plot function with the lines function together. The lines built-in function for the second line, and you can see the first parameter is the second line vector, and this second line that contains our sequence for that line for the second line from 3 to 13. And the second parameter is called type, to draw a line, also to draw the second line using the value of type, which is L in this case, like the first one also. And the last parameter, color or col parameter, is equal to blue for the second line and green for the first line. Now we need to run this program. To select all the code and hit Ctrl Enter or use the run button to show the output on the screen. You will see the output inside the plots tab or the plots section. Let's do that. After hitting Ctrl Enter or running this program using the run button, you can see the output inside the plots section. You can see the first line is green and the second line is blue. You can try this by yourself. Set different values for the first line and also different values for the second line. Change these sequences for the two lines and use different colors also. And if you need any help, please ask me and I'll answer you as soon as possible. Thank you so much for watching. See you again next lesson. In the R programming language, you can easily use pie charts to visualize data in a circle. The definition of pie chart in general: a pie chart is a circular graphical view of data. You can visualize the data simply in a circle with some details, and you can use the pie function in the R programming language to visualize data in pie charts, and I'll show you that in action. At the beginning, let's create a vector of values or a set of values to visualize the data for these values. We have a variable here, new pies, and we assign this vector of 4 items or 4 values to this special variable called new pies. And after that, you can see the pie function. This is a built-in function to visualize the data on the screen in a circular shape or in a circular graphical view, and this is called pie chart. You can see this pie chart on the screen here. For the first item, 15 is the smallest one in the circle, as you can see, 1. And also in this pie chart, 2 for 25, 3, the index number 3 for 35. This is the index number for this item inside this vector called new pies. And the last one that has the index 4 is 45 in this pie chart. And if you want to change these values, you can do that. You can set many values, not only 4 values like this example here. This is a simple example to clarify the concepts. And in this example, to print out the pie chart on the screen, you can see we use the pie function. And inside the round braces of that function, we placed the variable name, or our vector name in this case is called new pies inside the round braces. And once you select all the code here or all the example and hit Ctrl Enter, you will see the pie chart for data visualization on the screen inside the tab called plots or inside the plots panel. Or you can zoom in like that to show this pie chart clearly. In this example, by default, the plotting of the first pie chart starts from the x-axis and move with counterclockwise. And you can change the angle using the init angle parameter inside the round braces of the pie built-in function, exactly as in this example here. The init.angle parameter for pie charts in the R programming language is used to change the start angle of the pie chart. Exactly as in this example here, we set a value for the init angle, and this value is 90 as in this example. The value of init angle is defined with angle in degrees, where default angle is 0. If you want to remove this parameter, the default angle will be 0 in that case. To give some meaning for each section in the pie chart in R, you can use labels and headers for sections. Let's see how to use the label parameter in the R programming language with the pie built-in function to add a label to the pie chart. And also we will use a parameter called main, and this parameter is used to add a header for that pie chart. You can see here we have a sequence of labels called new labels: banana for 15, apple for 25, cherry for 35, and watermelon for 45 in this case. Once you run this program, you will see this output here: a header for each section in the pie chart: banana for 15, apple for 25, cherry for 35, and the last one, watermelon, for the biggest one, 45, the last one in the sequence. And inside the round braces of the pie built-in function to draw this pie chart, you can see the label parameter, and its value is new labels, the name of the variable that contains our labels we created previously. Also, you can add a color for each section in this pie chart. Let me show you how to use colors and also how to add the main parameter to add a header for this pie chart. As we did previously with labels, let's create another vector of colors, and this vector is called new colors. As you can see, yellow for banana, green for apple, red for cherry, and the last one black for watermelon. This is the vector of colors for our sections in this pie chart. After that, and before running this program, let's add these colors as a value for the color parameter or the col parameter in the round braces of the pie built-in function, and also let's add the main header using the main parameter. Just remove this parameter in init.angle parameter, and after that let's add the main parameter to add a header, and this header in this case is called fruits chart. And after that, the colors, and the value for this col parameter is the vector name new colors to add a color for each section in the pie chart. Now you need to run this program by selecting all the code and hit Ctrl Enter, or hit the run button to show the output in the plots tab or the plots section. But before running this program to show the result in the plots section, let's add a legend using the legend function to add a list of explanation below this pie chart for each pie or each section in this pie chart. Let's do that also. Inside the round braces of the legend built-in function, you can see the first parameter is bottom right. You can put it bottom, bottom left, left, top, top right, right, or center if you wish. The second parameter is the labels using the variable name, using the vector of labels called new labels, and the fill parameter to use the colors we set, the vector of colors. The value of fill is the new colors here. Done. Now we need to run this program. Select all the code and hit Ctrl Enter or use the run button, and you will see the output in the plots section. This is the full program here. Hit Ctrl Enter and you will see the output in the plots tab, or you can use the run button. This is our output here with colors, labels, and also legends. As you can see, banana, yellow, apple, green, cherry, red, and watermelon with the black color. The legend in this pie chart can be positioned using bottom right, the first parameter, or you can change it to bottom, bottom left, left, top, top right, right, or center if you wish. And also you can change labels, colors, values, and so on. Try to create different pie chart, and if you need any help, please ask me and I'll answer you as soon as possible. Thank you so much for watching. If you want to visualize data in bar charts or histograms in the R programming language, this is so easy to do. For bar charts, you can use the bar plot function, and for histograms, you can use the hist function. These functions are built-in functions. What is the definition of bar chart in general? A bar chart is a rectangular bars to visualize data for the statistical operations or mathematical operations horizontally or vertically by using the bar plot function in the R programming language. Also, in general, a histogram is a rectangular area to display or visualize the data of statistical information using the hist built-in function in the R programming language. And I'll show you how to use the bar charts and also histograms in the R programming language using the two functions easily, the bar plot function and also the hist function in R. Our first example is for the pie charts in the R programming language. You can use the bar plot function to display the data on the screen. We have values for x-axis and values also for y-axis, as you can see. X, the values for x, 10, 20, 30, 40, and the values for the y-axis is 30, 70, 80, and 90. Our points here 10, 30, 20, and 70, 30, and 80, 40, and 90 in this case. And you can see the bar plot function in this case. It has two parameters in this example here. Just call that function. You don't need to design that function from the ground up. The first argument is the y-axis. For the y-axis, to insert the points of the y-axis simply. And the second parameter inside the rounded braces of the bar plot function is called names.arg for the x-axis, and its value, as you can see using single equal sign, is the x variable. Names.arg is used to define the names of each observation in the x-axis in this example here. The x variable is used to represent values in the x-axis, the y variable is used to represent values in the y-axis, and you can see the bar plot function with the two parameters in this case. Now you need to run this program to show the output on the screen. You can select all the code from here and hit Ctrl Enter, or you can use the run button from the top side, and you will see the output for our program in this case inside the plots side or inside the plots panel. Exactly as you can see, this is the output for this program. If you want to change the color of the bar plot, you can do that by using the col parameter or the color parameter. In this case, you can see blue. You can change it, for example, to red, or any color you wish, for example, green in this case, or any color you wish. Type the name of the color and you will see the changes inside the plots side or inside the plots tab on the screen. As you can see for our bar chart for this example, you can change the color to any color you wish using the col parameter here. The col parameter is used to change the color of the bar charts easily, as in this example. If you want to change the bar texture, you can use the density parameter to change the density of this bar charts. As you can see, 5, change it to 8, and you can see 11 and 4, and change it to any number and see the results on the screen. In the plots tab, you can see the output. You can see the changes here. Change the value of density parameter inside the rounded braces of the bar plot function easily. The density parameter in the data visualization in R is used to change the bar texture or data visualization texture, as you can see as in this example. The width parameter in the bar charts in R is used to change the width of the bars, exactly as we will do here. the width parameter is equal to C, the C function, to combine these values, this set of values, and you can see the output on the screen. The width for each bar is changed based on these values: 2 for the first one, 3 for the second one, 4 for the third one, and 5 for the last one, the biggest one in this case. As you can see, the 40 bar is the biggest one based on the biggest value 5 in the sequence using the C built-in function. This is about the width parameter. The width parameter in the R programming language, you can use it for bar charts inside the round braces of the bar plot function to change the width of the bars as in this example. And feel free to change these values if you wish to see the difference in the output inside the plots tab or inside the plots panel here. Okay, what can we do if we want to display the data in the bar charts horizontally instead of using vertically like in this example? For this job, you can use the horiz parameter as in this example here and set the value of the horiz parameter to true. And you can see here our bar chart is changed from vertically to horizontally. The horiz parameter in our programming language inside the bar plot function is used to display the data in bar charts horizontally instead of visualizing the data vertically, exactly as in this output inside the plots tab. The hist built-in function in R is used to create histograms. Let's see that in action. We have degrees here, we have set of values, and we want to display these values in a histogram in the output inside the plots tab. We are using in this example the hist built-in function, and the first parameter is the set of values degrees, the second parameter xlab to add this title to the x-axis, the x-axis, ylab to add this title for the y-axis, and color is equal to red. Col is equal to red in this case using the col parameter. The border is equal to blue between each bar inside the histogram. Now you need to run this program to show the output on the screen, to show the histogram inside the plots tab. Let's select the program and hit Ctrl Enter or run the program from the run button to show the output inside the plots tab or panel. You can take a look at this output for this program. Our data visualization using histogram in this case. The title or the header for this data visualization is called histogram of degrees, the name of the sequence in this case. And the title for the x-axis or the label for the x-axis is the x-axis. You can change it to any text you wish. Also for the y-axis is called the y-axis text. You can see that in the data visualization or in the histogram here. You can see the color is red and the border between each bar is blue. You can change the colors if you wish also, and change the sequence or degrees. You can set any sequence and visualize the data using the hist built-in function in the R programming language to visualize the data in a histogram like this example here. I hope that you enjoyed this lesson. Thank you so much for watching.